Hi grade 12s and welcome to this video. In this video, we are going to be working on the Maths Paper 1 November 2023 paper. I also want to mention that I got this past paper from Essay Exam Papers, so you can also just go ahead and download it. Okay, so I don't want to waste any more time with this. Let us get into this video. So we start off with question 1. Okay, question 1.1.1, we have the usuals. So in this one, you have been given something that has not already been factorized. We have x squared plus x minus 12 is equal to 0. And so we have to factorize it. So we're going to open up two brackets, equate it to 0. And we're saying what times what gives us x squared, that's x times x. Now, what times what can give you negative 12, but in the middle will give you 1. So let's think about that. I can think of factors as 4 and 3. So 4 times 3 is 12. But then I can see that this is negative. So 1 should be negative. Which one should be negative so we can have a positive 1 in the middle? The 3 should be negative. So that's positive 4 minus 3, which gives you positive 1. So that's plus 4 and minus 3. And then we're just going to finally say that x is therefore equal to, we're taking the positive 4 over the equal to sign and becomes a negative 4. Or x is equal to, we're taking that over and it becomes a positive 3. So those are solutions. Okay, moving on to the next question. 1.1.2 says we have to find out, or basically solve for x, if we have 3x squared minus 2x is equal to 6, and you can already see correct to 2 decimal places, meaning use the quadratic formula. So let's look at that equation first. Is this okay to already start using the quadratic formula? No, it needs to be in standard form. So let's say 3x squared and we have minus 2x, then you need to bring the 6 over. So it's minus 6 is equal to 0. As we can see, our a value is 3, our b value is negative 2, and our c value is negative 6. So we're just going to put down the quadratic formula a. And so x is equal to negative, and what is our b? Is a negative 2 plus minus the square root of negative 2 all squared minus 4 times a, which is 3, and c, which is negative 6, and all over 2 times 3. Then you can just plug this onto the calculator and see what you get. I'm going to start with the plus first. Okay, so when I plug it in, my first answer when I put the plus, of course, is I get 1.786. If you round off to 2 decimal places, that's going to be 89. Or x is equal to, and you're just going to change that sign to say minus instead now. And so we get negative 1.12 rounded off to 2 decimal places because the 9 rounds up. Okay, so that would be our answer for this question. And then we move on to the next question, 1.1.3, which is on surds. So we have, first of all, the square root of 2x plus 1 is equal to x minus 1. Okay, and let me also just check. The mark allocation is 4 marks. So, okay. So, as you can see, the surd has already been isolated for you. You don't have to isolate the surd. So, that mark is probably what is missing there. So what I'm going to do is I'm just going to go ahead and get rid of this square root by squaring both sides. And then we're going to have 2x plus 1 is equal to, and then we're going to simplify this. Now you can go ahead and say this is x minus 1 multiplied by x minus 1 and FOIL that out. But I feel like that method takes quite long. So I deal with it like this. I say x all squared gives you x squared. And then I multiply the first and the second term together. So that's x times negative 1, which is negative x. And I take that and I multiply by 2. So negative x times 2 is negative 2x. And then I get a positive 1 when that gets squared, of course. So you see, square the first term, square the last term, multiply the 2, and multiply by 2. Okay, so that's what we have. And then I'm just going to simplify this. So I have 2x plus 1 is equal to, and I have to take things over. 0 is equal to x squared minus 2x. And I'm going to take that over and becomes a minus 2x. Then we still have the plus 1 on the right-hand side. And then I'm taking this over and becomes a minus 1. So 0 is equal to x squared. And that gives us a negative 4x. and those cancel because positive 1 and negative 1 is 0. Now we have this equation. We need to solve for x. So in this equation, it's still quadratic because you have x squared. What you have to do is, in order to solve for x, you see that x is common in the first and second term. Please be careful here. Do not divide by x ever because you don't know what x is. X could be 0. If you divide by 0, it just completely destroys your equation. It makes it undefined. Okay, so at this point, what we're just going to do is take x out as a common factor. And so then we're going to have x and minus 4. Okay, remaining, because that's what's left here. That's an x. And what's left here is a negative 4. Of course, if you take out the x. Okay, now that we have this, you see that x is being multiplied by x minus 4. Since they are multiplying, it's really just the same thing as when you saw in the first question. You see that these two were multiplying, and so we just made them equal to 0. We said x plus 4 is equal to 0, and this is equal to 0, and that's why we were able to end up with these answers. That's the exact same thing you're going to do here, because these two are multiplying by each other. You're going to equate them to 0. So if they're multiplying, it either means that x is equal to 0 or x minus 4 is equal to 0. And of course, if you take that negative 4 over, it becomes a positive 4. So x is either equal to 0 or x is equal to 4. Okay, so at this point, because of this, right, where you can see they already isolated the third for you, you didn't have to do that. I know that it is 4 marks, but then usually when we have to check whether our answers are correct or not, it's usually worth 5 marks. But the reason I'm now thinking we still have to check is because they already isolated the third for you. Okay, so even if you check in the 2022 paper, you'll see that you get a mark for isolating the root. Okay, so the mark is really, you get a mark for leaving the root on one side, isolating the root, and then you get a mark for squaring both sides. So this is where our mark is coming from. The root was already isolated, so we're not really getting a mark for isolating that root anymore. The thing about this is we have 1 mark here for squaring both sides. You also get a mark for putting it in standard form. So we put it in standard form, that's 1 mark. So long, this is only 2 marks. Then you get 1 mark for both answers. So in my head, I'm like, where's this 4th mark coming from? And I think it's going to come from actually checking your solutions, because this question is usually worth 5 marks. That's third question. But this time is worth 4 marks, but you can see that they already isolated the third. Okay, so I'm just going to check whether the answers are right. So check for our solutions. Let's just see. Our first solution is x is equal to 0. We are just going to put it back into the original equation. Of course, that one before it was squared. So that is the square root of 2. And what I'm substituting in place of x is going to be 0, because I want to test if 0 is actually a solution. Then I'm saying plus 1 is equal to, and it needs to be equal to the right hand side. So I have x here, so I'm going to say 0, and I have minus 1, and I can already see this is not going to work out because this is going to be negative. So that's negative 1. If you square root 2 times 0 is 0, so that is 0 plus 1, which is 1. Square root of 1 is 1. You know that 1 is not equal to negative 1. So clearly this is not your answer. Okay, but still check that one. Don't just say, oh, okay, then that means 4 is my answer. Sometimes both of them are not even solutions. Sometimes both of them are, and sometimes one is not and one is. So I'm going to again say 2 bracket, and then I have the 4. Then plus 1 is equal to, again, 4 minus 1. Sorry, minus 1. Okay, so let me see if this works out. So 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. 4 minus 1 is 3. That works out perfectly. Left is equal to right. So it means that x is equal to 4 only. So that is probably where the 4th mark is coming from. Okay, moving on to the next question. We have now 1.1.4. We have an inequality. So with inequalities, we're just going to first of all make sure that it is in its standard form so that we can actually factorize this. So this is what we were given. It needs to be in the form of ax squared plus bx plus c. So clearly we have to take this 2x over. So we're going to have x squared, And remember, it's bx, so it needs to come in between this. So minus 2x, then minus 3 is greater than 0. Then factorize. So open up two brackets. We're still saying greater than 0. We have x times x gives you x squared. Now what times what gives you 3? That can give you 2 in the middle. Specifically, what times what gives you negative 3? That can give you negative 2 in the middle. Well, 3 and 1 are factors of 3. So 3 times 1 gives you 3. Which one should be negative so that that middle will be negative? You have to give the negative to the 3, because negative 3 plus 1 is negative 2. So minus 3 and plus 1. Okay, so this is what we have. And now we're just going to solve for the inequalities. So I'm actually going to use a very simple method. I will not use a graph in this video. If you want to see how I use the graph interpretation, you can look at my previous videos. I also have a video on 2022's paper as well. So this is what I'm going to do. I'm just going to use a number line because I feel like it's quicker. I'm going to use a number line, and I need to first put down my critical values. My critical values are really just my x-intercept of this parabola that we have here. And that would be, you see, we have x minus 3. So it means that your critical value would be positive 3. It's kind of like taking this over the equal to sign. So I have a positive 3. And also looking at this x plus 1, the critical value would be negative 1, because you're going to take that over the equal to sign. And really what I'm doing is I'm going to put them on a number line in their correct order. So I know that negative 1 is smaller than positive 3, so it will go on the left and then the positive 3 on the right. And then all I'm going to do here is I'm going to write down one number that is smaller than negative 1, which is negative 2. Okay, that's smaller than negative 1. And then a number greater than negative 1, which is 0. And then with a 3, a number smaller than 3 is 2, and a number greater than 3 is 4. And all I'm going to do is I'm looking at these now, because it says greater than 0, not greater or equal to 0. I'll just have an open circle on top of the critical values. Now, I'm just going to substitute these values into this inequality, and it needs to give me a value that is actually greater than 0. So let's go ahead and try negative 2. We can try negative 2 and substitute it into this, and let's see what we get. And when I substitute that, I get 5. So it means that negative 2 is working. It is going towards that direction. Okay. And so when I'm writing this down as an answer, you see that this is just the inequality. When I'm writing down my answers, I'm saying x and I'm putting my critical value down. My first critical value is the negative 1. So x and negative 1, or I also have x and my other critical value is 3, right? Let me actually just keep them in the same color just so that it's easier to look at. Okay, now that we have this, right? I found out that it's working for values that are smaller than negative 1, because negative 2 worked. I tried negative 2 and it works. So it means that x is less than negative 1. Because it's working, this inequality is true for values that are less than negative 1. Okay, you can also just follow the arrow. You see that it worked for this. So you always have to substitute it in. When you get your answer, you check if it actually does satisfy that inequality. The inequality says your expression needs to be greater than 0. 5 is greater than 0, so it works. I'll do the same thing for 0. Okay, so for 3, sorry. I'll do the same thing for 3. So let's go ahead and substitute. Because the 1 going this way worked, by default, I'm going to try the 1 going this way. Okay, so let's try 4. I'm not even going to try 2. So go ahead and substitute 4 into there, and let's see what we get. We get 5, okay? So it's a parabola, it's 5, we get 5. And so it means that, yes, 5 is a value that is greater than 0. So this is also working for values that are greater than 3. So I'm saying that x has to be greater than 3. Again, the arrow really helps you with the inequality. You see, if you try 2, look what's going to happen. If you substitute 2 into that, you get a negative 3. That does not satisfy the inequality. The inequality says that this expression needs to be greater than 0, not less than 0. That's how you check whether it works or not. So this is the number line method. This is probably a method you'd have learned in grade 11. It is quite helpful. I like to use it sometimes, but it is good to remember the graph method as well because you will be working with graph interpretation a lot. Okay, so this is your answer, and here's my number line. So x is either less than -1 but greater than 3. And as you can see, they're not pointing towards each other, so the values are not related. I don't have to write them as one single inequality because they're pointing in different directions. Okay, moving on to the next question. Okay, 1.2 says, in 1.2, you see that we have a simultaneous equation. In simultaneous equations, quite simple. All you have to do is first identify which one is going to be equation 1. Always take the simple linear one as equation 1. So that would be this. This is a linear equation and it's quite simple. So I'm going to take that as equation 1, also because it has x sitting nicely on its own. It doesn't have a 2 in front of it or anything, so I can make it a subject. And then by default, that is equation 2. So I'm going to take equation 1, and from equation 1, I will create equation 3 by taking 2 over. So x is equal to, we still have 2y, then 2 comes over, minus 2. This is now our equation 3. Then we're just going to go ahead and substitute equation 3 into the equation we didn't use, equation 2. And so every time I see x, I will replace it with 2y minus 2. So that is 1 over, and I have x, so I'm saying 2y minus 2 plus 1 over y is equal to 1. Okay, and so here it's really just arithmetic that you need to just work around and then you can find your answer. We need to solve for y. But you can see that we have a fraction here and a fraction here. So why don't we just see that, okay, we are adding. So if we are adding fractions, the denominators need to be the same. So how can we make these denominators the same? Well, you're going to have to think about what should the common denominator be. At the end of the day, when you make the denominators the same, what will that denominator be, that common denominator? And we call that the LCD. Now, because you have 2y minus 2 and you have a y, your LCD has to be y multiplied by 2y minus 2. And let me not even complicate it by saying LCD and all that. All you're just trying to do is make the denominators the same. And so to make the denominators the same, the common denominator must be this. And really, I'll just show you in slow motion what I'm really trying to do. To make the denominators the same, the only way is to get the denominator to become this. So when I have this fraction, how can I get this denominator to become like this? Well, it has the 2y minus 2, but it doesn't have the y. So I just have to multiply it by y. But what I do on the bottom, I must do on the top. That way, I'm not tampering with the value of this. I'm just tampering with the way it looks. Okay, then I have to do the same to this. Well, not the same thing, but I also have to multiply by something so that its denominator also looks like this. So we have the y. We don't have the 2y minus 2. So I just have to multiply this by 2y minus 2 on the bottom and on the top as well. And then this is 1. Okay, as a fraction, 1, you can write it as 1 over 1. And so if you also wanted to make sure that it has the same common denominator, as you can see, it just has a 1. So the only way to do that is to multiply it by y times 2y minus 2, so that its denominator is actually that. That's what the lowest common denominator is. It's what all the denominators of the fractions are going to become. Okay, so on top as well, I have to do the same thing. And then now this is what we have. So we just have 1 times y, which is y, and then plus we have 1 multiplied by 2y minus 2, which is just 2y minus 2 over, now they have the exact same denominator. Do you see that this multiplied together and this, they're exactly the same thing. They're the lowest common denominator. So that is y bracket 2y minus 2. I can put them together now, okay, because that got added to that. And then it's equal to this as well, y bracket 2y minus 2 over y bracket 2y minus 2. Now, because the denominators are the same and this is an equation, only in equations, not expressions, you can drop the denominators. You can let go of them and focus on the numerators, because the whole point is we have made them equivalent fractions. Now that they're equivalent fractions, we can just focus on solving for y. So we're just going to focus on the numerators now. So we're saying therefore, y plus 2y minus 2 is equal to, and I have y bracket 2y minus 2. And I just have to simplify this. So this is going to be, I have y plus 2y, which is 3y minus 2 is equal to, and I'll just distribute that. So y times 2y is 2y squared, y times negative 2 is negative 2y. Then we have 0 is equal to 2y squared. I'm taking these over. And then I still have a minus 2y on this right hand side. I'm taking that over, it becomes a minus 3y. Taking this over, it becomes a positive 2. So 0 is equal to, we have 2y squared, and negative 2y minus 3y is negative 5y. And then we have plus 2. Okay, so we have to factorize that. So when factorizing this, there is another method. It's called the cross method. But remember, you could use the quadratic formula and still get to the answer. Please make sure to check in my past videos on, you can even use the 2022's paper. I do explain these things. Okay, so what I'm just going to do here is I'm saying that I have 2y. What do I have to multiply to get 2y squared? 2y times y. That will give me 2y squared. And what do I have to multiply to get 2? Well, that's just 2 times 1. But it depends on how I put them. So I will put it as 1 and 2 so that that can create a 4. I also noticed that the 5, right, is negative. It's the only negative term in this trinomial. So it means that both of these are going to be negative. That's why that's positive, because you said a negative 1 times a negative 2, it became positive 2. And that's why the middle is negative. Okay, so I'm going to cross multiply, and that's why it's called the cross method, to check whether it's actually correct, whether it really does give me a negative 5 in the middle. So 2y times negative 2 is negative 4y, and y times negative 1 is negative y. Negative 4y minus y is negative 5y. So that works out perfectly, and I know these are my factors. So 0 is equal to 2y minus 1 bracket y minus 2. And then I just have to solve for y. So solving for y, I'm just going to say 2y, okay, minus 1 of course is equal to 0, but you're going to take that negative 1 over, and it's going to become a positive 1. Or we have y minus 2, which is equal to 0. And you're just, of course, going to take that negative 2 over. So it becomes y is equal to 2. Here, divide both sides by 2. So y is equal to a half, or y is equal to 2. Those are our two solutions for y. Now, that's just y. That's not x yet. We need to solve for x and y simultaneously. So since we have y, how do we find x? Well, look at the three equations that we have. The third equation starts with x is equal to. So we're going to use that equation. So x is equal to 2y minus 2. If you like, you can go ahead and say, this is my equation 4. And in order to find that x, I'll just substitute equation 4 into equation 3. We're going to use that. So we know now that equation 3 says x is equal to 2y minus 2, right? So in place of y, we're just going to substitute our y value. And our y value, the first one is a half. So that is a half. Okay, so if you have, you can just substitute that into the calculator though. So 2 times a half is 1, because the 2's cancel. 1 minus 2 is negative 1. So that's negative 1. Or we have x is equal to 2 times, and the next one we have is 2. So that's 2, and then, sorry, supposed to be in color 2. And then we have minus 2. So 2 times 2 is 4 minus 2, which is 2. So there's our answers. It's either that x is equal to negative 1 and y is equal to a half, or that x is equal to 2 and y is equal to 2. Those are our point of intersection, really, because that's what a simultaneous equation is. It's two graphs that are intersecting, and you're finding the x and the y values of the points of intersection. Okay, so that is 1.2 done, and now we are on 1.3. So 1.3's question is, they say 2 to the power of m plus 1 plus 2 to the power of m is equal to 3 to the power of n plus 2 minus 3 to the power of n. Okay, given this, where m and n are integers, you need to determine the value of m plus n. So if you can just solve for m and n, you'll be able to find that. As you can see, this is an exponential. So let's write that down quickly. This is just an exponential expression. So we have 2 to the power of m plus 1 plus 2 to the power of m is equal to 3 to the power of n plus 2 and minus 3 to the power of n. Okay, so since this is just an exponential, let's go ahead and focus on the exponents. What we can do is to see what is going on here first, or to see what is maybe common. We can break up those exponents that are joined together. Remember how if you have the same base and you're multiplying something, you're just going to keep the base the same and add the exponents, right? That's how we're going to separate this. So it means 2 to the power of m plus 1 was created by saying 2 to the power of m multiplied by 2 to the power of 1. That's how we got that. And then we just have plus 2 to the power of m, right? And then that also means that 3 to the power of n plus 2 was created by saying 3 to the power of n multiplied by 3 to the power of 2. Then we have minus 3 to the power of n. Now, do you see that if you look across all of these, do you see something that is repeating? Okay, here, what is common between the first and the second term? That would be 2 to the power of m. So we're going to take that out as a common factor. Open a bracket and we have 2 to the power of 1, or just 2. Then, so that is the first term. And then what's left in the second term? Well, what do you multiply to 2 to the power of m to get back to 2 to the power of m? That would be 1. And that is equal to, we also have here, do you see that there's also a common factor between the two terms here? That is 3 to the power of n. That is common. So that's 3 to the power of n out as a common factor. What do you multiply to this to get back to this? Well, this is already there, so you must multiply by 3 to the power of 2. And what do you multiply to this to get back to this? Well, we'll have a negative this time. So it's a negative 1. Okay. So this is equal to, we have 2 to the power of m times 3, which is equal to 3 to the power of n. And this is going to be 9 minus 1, which is 8. And this is so funny because I remember I was prepping a matric student and I literally told her that I think this question is probably going to show up again, because I kept seeing a pattern of them bringing up this question and they literally put it in again. So you guys, you should try and get used to these questions, these exponential ones, this format specifically. Okay, so what I'm seeing here is a repetition of 3s and 2s, okay, as bases, which is great. So I can see a base of 2, a base of 3, base of 3, but that is not a base of 2, but we can write it as a base of 2. 8 can be written as 2 to the power of 3. So if you rewrite this, this is what we have, right? We have 3 to the power of n times 2 to the power of 3. And in here, we have 2 to the power of m multiplied by, and they're really just being multiplied by 3. And that's also being multiplied. Okay, so you see that the same operation is being used. So if we have 2 to the power of m, right? We will equate that with the 2 to the power of 3. I also explained this in that 2022 paper more deeply, but I don't want to waste too much time with these explanations. So you can also just check that video out. So this would mean that 2 to the power of m would be exactly the same thing as 2 to the power of 3. We're equating it like that. And this would mean that the 3's would also go together. The 3 to the power of an invisible one is equal to the 3 to the power of n. And by the law of exponential equations, when the bases are the same, you can make the exponents equal. So it means that m is actually equal to 3 and n is equal to an invisible exponent of 1. So there we go. But remember, the question says you need to determine the value of m plus n. So therefore, m plus n is finally equal to 3. That's m plus 1, which is equal to 4. And that is our answer. Okay, so that is it for question 1. Moving on to question 2. Okay, so first question, we have 2.1.1, which says we have 7 plus 12 plus 17, and this keeps going. And it's an arithmetic sequence. So they just want us to find, the first question is, we just have to find the value of T91. do not be extra. Don't go ahead and find the whole pattern's general formula. Just stick to this question. They want you to find T91. Well, this is an arithmetic pattern, so the Tn pattern is Tn is equal to A plus n minus 1 times D. And all I'm going to do is literally just substitute. So T what? They want you to find T91, term 91, is equal to A. What does A stand for? Well, A is always your first term. So that is 7 plus, what is n again? N does not change. It's still 91. So 91 minus 1. And then what is our difference? And now we can just easily see the difference. If you say 17 minus 12, that gives you 5. And you can also double check by saying 12 minus 7. That also gives you 5. So you can also see now that D is equal to 5. And you know that A is equal to 7. So, and times 5. And you're just going to put that onto the calculator, or you can calculate it manually, but it's best to trust the calculator in an exam. And then we just find our answer. Also, if you want to put it properly on the calculator, make sure you put brackets around that because the calculator will not understand otherwise. So 457 is our answer. Okay, moving on to the next question. The next question says calculate S of 91. S91. The sum of 91 terms. Interesting because they asked us to calculate the value of term 91. So since they want us to find the sum of 91 terms, remember that they already told us to find T91. So this is the last term. So we're going to use this formula, 2.1.3. We're just going to use Sn is equal to n over 2 multiplied by A plus L because we already have the first term and we have the last term. So S91 is equal to 91 over 2. A is 7 plus the last term is 457. We found that. And you can just go ahead and substitute that and let's see what we get. And we get this number 21112. Okay, 21112. And that is the sum of 91 terms. Moving on to the next question. The next question says we need to calculate the value of n for which Tn would be equal to 517. So it's really just saying there's this term, right, that has a value of 517 and you need to find the term. And they really placed it in they put it in a very simple way. Sorry, I noticed I said 2.1.3. This is 2.1.2. Okay, so for 2.1.3, what we're just going to do is find n if Tn is equal to 517. So Tn, we know our formula now. It's A plus, but we already know what A is. It's 7 plus n minus 1 times D, which we know is 5. All we're going to do is, in place of Tn, substitute 517. It's equal to 7 plus n minus 1 times 5. So I like to simplify it this way, where I'm going to take the 7 over because I can see that there are two separate terms here. That's the first term, second term. So take 7 over. 517 minus 7 is 510. And then now this, you see this is two terms being multiplied by one term. You can rewrite this as 5 bracket n minus 1. I'm not going to distribute because it just takes longer. I feel like it takes longer. Then I'm just going to get rid of the 5 by dividing both hand sides by 5. 500 divided by 5 is 100. 10 divided by 5 is 2. So we have 102 is equal to n minus 1. Then you're just going to take the 1 over, and when you take the 1 over the equal to sign, that's just going to give you a plus 1. So 102 plus 1 is 103, and that is our value of n. Okay, moving on to the next question. Next question 2.2. Okay, so the next question says the following information is given about a quadratic number pattern. So this is the information. Term 1 is equal to 3. Okay, great. So we have a quadratic pattern and they're saying term 1 is equal to 3. And this is how you should put things, structure them down. As they're telling you the things, be writing it down so that you don't get intimidated by the question. Okay, so I'm just saying term 1 is 3. Okay, that's my first term in my quadratic pattern. Then they say term 2 minus term 1 is 9. Well, they told us term 1. And so if they're saying term 2 minus term 1 is 9, then that means I can easily find this term 2 they're talking about because I know what term 1 is. So term 2 minus term 1 is 3, is 9, right? So that's term 2 minus 3 is 9. So if I take this over, this negative 3 over, term 2 is equal to 9 plus 3, which is 12. So I know what term 2 is 12. And I'm also just going to really take into account that they specifically say term 2 minus term 1. Term 2 minus term 1 is 9. Okay, so that's the information we have so long. Then they also say, what else do they say? They tell us, and T3 minus T2 is equal to 21. T3 minus T2, again, another thing like that. T3 minus T2 is equal to 21. So I can also use this information to find T3, possibly, yeah? So T3 minus T2 is 21, but I know what T2 is now. T2 is 12, so minus 12 is equal to 21. Take negative 12 over, then it means that T3 is actually equal to 21 plus 12, and so that will give you 33. So T3 is 33. That's what we have, okay? So this is what our pattern looks like. Okay, quadratic, these are the differences, the first differences. The first question is for us to find or to show that T5 is equal to 111. So let's see how we can find that. We have T3, right? We just need to find T5. That doesn't seem so bad because this is a quadratic. So in order to find T5, why don't we just first of all find that constant difference, because we know it's going to be constant, right? Because there's T4, then there's T5. We just have to get to here. Okay, so 21 minus 9, what's that going to be? 21 minus 9, that's 8. 20 minus 8 is 12, so 12. And so now that we have this 12, what can we go ahead and do? We're just going to say that because we know this is the constant difference, second constant difference, okay? It's always going to be constant or really just the same. So here I'm also going to have a 12. So to find now the third term of the first difference, I would say 21 plus 12, which is 33 also, okay? Weirdly enough, it's also 33. Now to find the fourth term, I would just say T3, right, plus the 33, which would be 66. Then to find the fifth term, I'm going to do the exact same thing all over again. So I know that the constant difference is constant, so I will have a 12. So 33 plus 12, that is 45. Then 66 plus 45, 60 plus 40 is 100. 6 plus 5 is 11, so 111. There we go. And that's how I would find that. Okay, so there. This is going to be our proof that that's how we found what that is. Of course, with your equations, but I didn't really see a need of putting the equations down. It may be necessary, but it's only for 2 marks, so they probably just want to see that really. Okay, so T5 is therefore equal to 111. Okay, so that is 2.1.1. Moving on to the next question. The next question, 2.2.2. They say show that the general term of the quadratic pattern is this. You just have to find the general term. We already have all of this simplified. So all you're going to do here is, you see the second constant difference, you're going to make that equal to 2a. Okay, that's first term, of course, right? So, and then we're going to look at the first term in this row, and you're going to make that equal to 3a plus b. And then the third term in this row, you're going to make that equal to a plus b plus c. That's all. Okay, so let's start from the bottom. You always start from the bottom. So 2a is equal to 12. And then if you divide both sides by 2, a is going to be equal to 6. So there we already have that 6. Then they also tell us we have to, well, we're just trying to find b. So 3a, but I know what a is. It's 6 plus b is equal to 9. Okay, so b is equal to 3 times 6 is 18. So we still have 9 here. This becomes an 18. It comes over and becomes a negative 18. B is equal to 9 minus 18, negative 9, because it's double of 18. 9 is double of 18. And then to find C, A plus B plus C. So A is 6, B is negative 9, so minus 9, plus C. and then that's equal to that number 3. So let's just go ahead and simplify this. So I'm saying that C is equal to, I still have the 3, but 6 minus 9 is equal to negative 3. If you take negative 3 over, it becomes a positive 3. So C is equal to positive 6. And there we go. Okay, so there you have A, B, and C. So it means that Tn truly is equal to 6n squared minus 9n plus 6. Okay, moving on to the next question. Okay, so the next question is 2.2.3. And 2.2.3 says, we need to show that the pattern is increasing for all where n is an element of natural numbers. Remember, natural numbers are numbers that start from 1, and they're not fractions, they're not decimals, they're not surds, they're just whole numbers starting from 1, okay, so all the way to infinity, of course, right? So we need to show that this pattern is increasing. Well, if you think about how a pattern, or really thinking about an increasing pattern, this is a parabola. We already have the formula for the parabola, right? Because it's a quadratic equation, a quadratic pattern that forms a parabola. And as you can see, do you see that the first term is positive? So first of all, since the first term is positive, I'm already saying since a is greater than 0, right? We have a parabola that is concave up, or a smiley face parabola, right? We have that type of parabola. And so we need to now find out for which, not really for which values. We're not finding out anything. We're just showing them. We're showing them that the pattern is going to increase where n is an element of natural numbers. So we already know n can't be negative. Well, the only way for you to find this is to actually find really, because when you're looking at a parabola and when it's increasing. So I'm looking at a parabola like this. And to find out where this parabola is increasing, I would have to find the turning point of this parabola. If I can find the turning point, because here's the axis of symmetry of this. If I find the turning point, do you see that if you look on the left, right? You see what this parabola is doing here. You always read graphs reading from left, going all the way to right. So this graph is actually decreasing, moving from left to right. Where it starts to increase is here. So to show them that it's increasing, I need to find out exactly what this value is, okay? The n value, or the x value of that turning point is. And it's going to be a specific number that will probably be maybe positive. It has to be positive, or 0. But I would be able to see that after this point, this graph is going to move up just because of the shape of it, really. So really, I'm just going to find out what exactly that x value of the turning point is. And then after that point, we know that this thing is going to just increase. I feel like this question is more of a substitute for that question that they would ask when they would say, determine the value of n for which this would be a minimum, the expression will be a minimum or maximum. I think this is a substitute for that kind of question. Okay, so this is what we have. I'm just going to find that x value of the turning point. You can use two methods. You can use calculus, derive this, and set it equal to 0. Or you can use the equation of the axis of symmetry, which is x is equal to negative b over 2a, right? And so negative b, what is our b value here? So this is still in the form of an squared plus bn plus c. So b is negative 9 over 2 times a is 6. So that's what we have there. Okay, so what is negative 9 over, well, that's going to be positive 9. 2 times 6 is 12. And you can see that these two have 3 in common. So if you simplify that, 9 divided by 3 is 3. 12 divided by 3 is 4. So we have 3 over 4. Okay, so 3 over 4 is a improper fraction, but that's okay because the question is really just, you need to show them that the pattern is going to increase. Well, we know that since a is greater than 0, and this is the turning point, or really the x value of the turning point, right? So if that's the x value of the turning point, 3 over 4, right? then everything after 3 over 4, do you see that this graph is going to increase for that? And because it is a pattern, we are going to be using natural numbers really. Okay, you will not use negative numbers for the end values of a pattern. So since this is already a positive number, it's always going to be increasing. Okay, so we can just conclude and say that Tn is equal to 6n squared minus 9n plus 6, of course, will be increasing where n is, of course, greater than 3 over 4, right? And n is an element of natural numbers. That's what's going to happen generally, and it's always going to increase like that because we have a positive number here. Okay, so that is the last question of question 2. So we move on to question 3. Okay, so now we're on question 3, and 3.1, we have a series. So it's 3 plus 6 plus 12, and it's going till n terms. And they tell us that it's geometric. Okay, so in this pattern, the first question that we are given is we need to write down the general term of the series. Okay, so it is a geometric pattern. In order to find the general term, all you need is the value of a, which we can say is 3, and the value of r, which we can find by saying term 2 divided by term 1, which is going to be 6 over 3 is 2. You can also confirm this by saying term 3 divided by term 2. 12 divided by 6 is also 2. So we have a and r. We can just say Tn is equal to a, which is 3, multiplied by r, which is 2, raised to the power of n minus 1, and that is our formula. Okay, moving on to the next question. 3.1.2, they want us to calculate the value of k such that this, where we have the sum beginning from p being equal to 1, right, ending at k, which is great, ending at k, and I'm glad that we're starting at 1, where we have 3 over 2 multiplied by 2 to the power of p is equal to this. Okay, do you see that the ratio here as well is also 2, right? They did not they will not go ahead and just introduce a brand new equation all of a sudden. You see that this is a followed question. Okay, it comes after that. And we can also see that here we have 2 as the ratio, here we also have 2. The only thing they did here with this p, I'm noticing this became a 3 over 2 because you see this 2 is raised to the power of n, which you can see as the p, right? And it has a minus 1. If you separate it, it's 2 to the power of p times 2 to the power of negative 1. It's kind of like just seeing, oh, okay, this is negative. So because it's negative, the law of exponents says, if this thing is negative and I want to make that exponent positive, I'm just going to take it from where it currently is, right? If it's on the numerator, I will move it to the denominator. Right now, it's on the numerator. Every number and variable on their own, if they're not as a fraction, they're on the numerator. So all they did was they just pulled that to the bottom. And that's probably what's going on there. So that explains that 2 to the power of p over the 2. Just the 3 was a coefficient, so it just ended up being like that. And so they just put the 3 to be over the 2. It would still mean the same thing, really. Okay, so it's not a new, all I'm just trying to say here, it's not a new pattern, it's the same pattern. They just modified the way it looks. Okay, so in this question, we just have to find the value of k. So let's us just carefully see what they're speaking about. Please do also check other questions with sigma in it because it can be confusing sometimes, but this one is quite straightforward though. Remember that in sigma notation, this is where you start, this is where you end. But if you want to find how many terms there are in this series, you need to count them like this. To find out the number of terms, you must say the top number minus the bottom number, right? Plus 1. The reason for this rule is because some patterns don't necessarily start at 1. Sometimes they can start at 0 or 2. And so to make sure that you do find out the amount of terms there are in the series, you use this formula, okay? But you see that in this one, there's no confusion. P is equal to 1. We have nothing to worry about. We can easily just find k. Okay, to find k, you're just going to have to find out where exactly the term ends. the value of k is literally how many terms there are in this series because p starts at 1. Okay, so I'm just going to use the sum formula. Since I know the sum of the series, okay, the sum of the series is the sum of n terms, because I don't know the amount of n yet, or k terms, is equal to 98301, right? I, however, know the first term. The first term is 3. Okay, I also know the value of r. So this is, sorry, it's a 2, right? I know all of these already, so I can go ahead and just find the value of k. And this is how I'm going to find the value of k. Okay, so in this equation, and really what I was trying to show you in that first part is, you see the value of k is literally going to be whatever your value of n is here. Okay, there's no confusion because p is starting at 1. So for example, let's say I said k was 10, right? Remember that n specifically stands for the number of terms. K is just where you end off, right? So if you think about it like that, how many terms would there be here if k was equal to 10? There would be 10 terms. There's no confusion in this one because p started from 1. So whenever you see that whatever the starting value here is 1, then the value that you have here is going to be where you end, first of all, but it's also going to be the amount of terms that you have. So there's no confusion with this one. K is n. You can substitute k in place of that, which I'm going to do. So Sn is, so let me just go ahead and put this down. This is 98301 is equal to, and our a value is 3. We're multiplying by 2 raised to the power of n, which I'm going to call k. Okay. And then we have minus 1 all over, and then r is 2 again, minus 1. Okay, so we just have to simplify this. It's just arithmetic, that's all. So when simplifying this, we're just going to say 2 minus 1 is 1. So you have 98301 is equal to, since this is 1, anything over 1 is just going to stay exactly the same, right? So this is what we have. Then I can get rid of the 3 by dividing both sides by 3. So if we divide both sides by 3, let's see what we get here. Here, we're going to get 32,767. And this is equal to 2 to the power of k still, minus 1. Then if you take the 1 over, it becomes a positive 1, making this 32,768 is equal to 2 to the power of n. Then this, because this is an exponential, you can use log or you can use exponential equations. So I know that since this is an exponential equation, since we have an exponent there, I'm just going to make the bases the same. So I'm going to put this as a base of 2 by saying 32768 is equal to, and I'm going to just say shift and press the factorize button, fact. See that degrees and 3 commas. And it gives me 2 to the power of 15. So it means this is 2 to the power of 15. And it's equal to 2 to the power of n. By the law of exponents, if you have the same basis in an equation, you can make the exponents equal. So it means that n, or rather k, why did I start writing it as n? K is equal to 15. Okay, and that is our answer. There's no confusion with that one because it started at p is equal to 1. Okay, moving on to the next question. So the next question is 3.2, and this is what 3.2 says. It says that a geometric sequence and an arithmetic sequence have the same first term. You see, the minute they start saying stuff like this, I don't even read the rest of the question. I just start writing down because I don't like to get intimidated by the question. Sometimes you scare yourself before you even work on the question. So to not scare yourself, you have to calm down and analyze what's going on. As they are saying what's going on, be writing it down, be representing it in a way that you will understand. So I heard a geometric sequence and an arithmetic sequence have the same first term. So this is what I'm going to do. I'm saying I have a geometric sequence and I have an arithmetic sequence. That's what I'm doing now. Okay, 2 sequences. And they're saying that they have the same first term. So if this first term's name is A, that first term's name is also A. It's exactly the same thing. Then the next thing they say is this. The common ratio of the geometric sequence is 1 over 3. So this is of the geometric. The common ratio R is 1 over 3. Then they say the common difference of the arithmetic sequence is 3. That's D is equal to 3. Okay, so that's what we have so long. Then this is what they're saying. The sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence. Let's break that down. So, the sum of the 22 terms of an arithmetic sequence. So here we have the sum of 22 terms. That's what we're speaking about, right? Sum of 22 terms of an arithmetic sequence is 734 more, right, than whatever the sum to infinity of the geometric sequence is. So there's the sum to infinity of the geometric sequence, but this sum of 22 terms is 734 more than that. That's why I'm adding. So 734 plus the sum to infinity, okay, of that geometric sequence. So that means here we have a geometric sequence, sum to infinity, right? We're going to find the sum to infinity here, and then they're telling us that the sum of 22 terms is this amount more than the sum to infinity. So something that we can do here is I can just say, okay, fine. Why don't I just let the sum to infinity, and I'll call that x. I'll just call that x. X is equal to this, right? So it means that, or let me say sum to infinity is equal to x. Then I just have to find what exactly the sum of 22 terms is. I know that this is 734 plus the sum to infinity, which I've called x. Okay, so you see now we have two equations, the sum to infinity and the sum of 22 terms, and they both include x. I've just decided to call that sum to infinity x. Okay, so this is technically not an equation, I'm just naming this. Okay, so the question is calculate the value of the first term. The first term is the value of a, so that's what we have to find. And they told us that a is exactly the same. So we're just going to have to use what they've given us. In the geometric sequence they told us information about the sum to infinity. So we're going to go ahead and try and find the sum to infinity. Remember, that sum to infinity, I'm calling that x. So that sum to infinity we calculate by saying a over 1 minus r. And so that sum to infinity, which I'm calling x, is equal to a. We don't know what a is, but a is exactly the same here, over 1 minus 1 over 3. And so 1 over 3, 1 minus 1 over 3 is 2 over 3. So that's a over 2 over 3. And if you simplify this, and let me actually simplify it here because you can't really do this on the calculator. It's the same thing as saying a divided by 2 over 3. So if you're dividing by a fraction, you're going to have to leave this exactly as it is, and you're going to tip n times. So you're going to tip this, swap the numerator and denominator, and then turn that into a times or multiply. So numerator times numerator, remember this is on the numerator, right? Numerator times numerator, that's 3a. Denominator times denominator, that's 2. So that's actually what the sum to infinity is, or that's what x is. Found that part. Okay, that's the sum to infinity of this geometric sequence, as long as we don't have a, of course. Then we have to find the sum of 22 terms. So let's go ahead and find the sum of 22 terms. The sum of 22 terms of this, since they gave us d, we're going to have to use that sum formula that includes d, which is Sn is equal to n over 2 bracket 2a plus n minus 1 multiplied by d. And so we're saying the sum of 22 terms is equal to 22 over 2 multiplied by 2 times a. We don't know what a is, so I'm leaving that as 2a multiplied by 22 minus 1 multiplied by d, which they told us is 3. Okay, so this is what we have, right? Now I can fill in place of s of 22. I know that this is equal to 734 plus x. So I'm going to just replace that. 734 plus x, which is equal to 22 divided by 2 is 11. And then we're multiplying, we have 2a. this is going to multiply together. So 22 minus 1 is 21 times 3. 21 times 3 is 63. So that's plus 63. And it's positive because we have a plus here, which I forgot. And then this is what we have. Then I can just distribute that. So 734 plus x is equal to, and I have 11 times 2, which is 22a. 11 times 63. Okay, let me see what that is. And that is positive 693. And then look at this. You see, this is an equation. Here we have x, and we also have x here. What you can just do is to solve for a, we can just make x the subject in both. Okay, x is already the subject here, just make it the subject here. Or you could have just taken this and substituted into the equation. You would have still gotten to the answer. Okay, but I'm just going to make x the subject. So I'm saying x is equal to 22a plus 693 minus 734. So what's 693 minus 734? That is negative 41. So x is equal to, we have 22a minus 41. Okay, so I have a formula for x on both sides. So I'm just going to equate my formulas for x. So I can just say that x is equal to x. So here, let me put this one because this has a bigger value. So 22a minus 41 is equal to, the other x is 3a over 2, which you can really just see as 3 over 2a. See, you can rewrite it like that. And so this is going to be equal to, and we're going to have 22a, and we're taking this over because it's an a, so it becomes minus 3 over 2a. It's equal to, take the number over because like terms together, positive 41. What is 22 over 2? Okay, you can use a calculator, but I'm just going to be like 44 over 2. And so 44 minus 3 is 41. So 41 over 2a is equal to 41. And then we're just going to divide both sides by 41 over 2. Divide by 41 over 2. And so you can again use a calculator, but a here would be equal to, numerator will cancel with denominator times, so 2. Okay, so a is going to be equal to 2. You can use a calculator, you will get to the answer still. And there, so that's our answer. The first term is 2. First term is 2. And that's our answer in question 3. Okay, so then we move on to functions question 4. Okay, so we are on question 4, and question 4 says this. They say, sketched below is the graph of f of x, which is equal to, we have 2 to the power of x minus 4, so we have an exponential function. Okay, and for x, x is an element of negative 2 to 4. Okay, so that's something we'll probably have to look at. And then we have a and b are respectively the y and x intercepts of f. So here's a and b. Okay, the first question, usually simple ones. You see, usually these questions, this is your places to score marks. If the last question gives you a headache, just skip. It is better to lose 2 marks than to spend 10 minutes on a 2-mark question. Okay. Then we have 4.1 says, 4.1, determine the equation of the asymptote of f. Well, f is an exponential function. The asymptote that it has is a horizontal asymptote. And that shows here in the equation. See, we have 2 to the power of x minus 4. That minus 4 is showing you your horizontal asymptote. Because this is a horizontal line, it will start with y is equal to, not x is equal to, because it passes the y-axis, and then we're saying y is equal to whatever number it passes the y-axis at. We can see that number here, that minus 4. Okay, so y is equal to negative 4. So whatever has the exponents, whatever is the coefficient of it, like if it was something like this, that part you don't take. You take that part. And if there's nothing there, it means that it's 0. Okay, so I may just make small explanations like that. So it means that y is equal to negative 4. Because that's the number that we have there. It's a negative 4. Okay, next question. They want us to calculate the coordinates of B. Well, what is B? B is the x-intercept of this graph. The x-intercept, how do you calculate that? You calculate the x-intercept by making y equal to 0. Make y equal to 0 to find x-intercept. So we're just going to say f of x is equal to 2 to the power of x minus 4. And we're substituting in place of y 0. So f of x now becomes 0 because it's y to the power of x minus 4. I can see this is negative, so I'll take it over. It's now positive 4 is equal to 2 to the power of x. And then this is an exponential. So exponential, you have to make the basis the same. 4 can be written as 2 squared. It's equal to 2 to the power of x. And so therefore x is equal to, equate your exponents, x is equal to 2. Okay, so since x is equal to 2, the coordinates of B, because it's an x-intercept, is B is going to be, the x value is 2, the y value is 0, because it's an x-intercept. That's why we made y equal to 0. Moving on to the next question, 4.3. 4.3 says, determine the equation of k, which is a straight line passing through A and B, in the form of k of x is equal to that. Very simple. It's just a straight line. It's passing A and B. So to find the equation of the line passing through A and B, you just have to find the gradient of that line, and you need at least 1 point. So to find the gradient of a line, you need 2 points by default. Okay. So to find that gradient, I have B because it's one of the points it passes on. Now, which point do I need? I need A because it's the second point that it passes through. So how do I find A? Well, A, as you can see, is your y-intercept. So how do you find the y-intercept? By making x equal to 0. So I'm taking f of x is equal to 2 to the power of x minus 4. And I'm just going to make x equal to 0. 2 to the power of 0 minus 4, f of 0 is equal to anything to the power of 0 is 1. So that's 1 minus 4. 1 minus 4 is negative 3. So it means that A is actually, the x value is 0 because it's an y-intercept, and the y value is negative 3. There we go. We have 2 points now. We can use this to find the equation of that line. So you're going to find the gradient of it first of all. So remember, we are using these 2 points. So the gradient of AB, you say y2 minus y1, so 0 minus negative 3. 0 minus negative 3 really just becomes 0 plus 3, so over, and y2, x2, sorry, minus x1, which is 2 minus 0. Okay, so that's going to be 3 over 2. Okay, so gradient is 3 over 2. Now that we have the gradient, we can substitute it into the equation of a straight line. Now, you can use the equation y is equal to mx plus c. Then substitute your m and one other point. I'm just going to choose b because it doesn't have negatives. I like stuff without negatives. So 2 and 0. This is my x and my y value. You can just use that and substitute. Let's just go ahead and do that. I was going to use a different method, but it's okay. So my y value is 0. M I now know is 3 over 2. X is 2. And I have plus c. I just have to find c. So 0 is equal to 3 over 2. Oh, that's multiplying. So the 2's will cancel. You can use a calculator, but I'm looking at it as a fraction. Those 2's will cancel. So when they cancel, you just have 3 plus c. If you take 3 over, you have negative 3 is equal to c. So therefore, y is equal to, our gradient was 3 over 2. So we have 3 over 2x minus 3. And that's our answer. Okay, so that looks fine. 3 over 2x plus minus 3. And moving on to the next question. So you see, first 3 questions, that was fine. Okay, moving on to the next question. It says, calculate the vertical distance between K and F at x is equal to 1. So they're telling you where exactly to calculate this. So we're going to end up with a number, not just an expression in terms of x. So for me to find the vertical distance between F and K, or K and F, I first have to see which one is above which one. Because if you want to find the distance of a line, you need a point that is above and a point that is below so that you can say the top minus the bottom. So I need to know which one is above, okay, and which one is below. Is k above f? Well, where x is equal to 1, right? Let's think about that. We know what b is now. B is 2, right? We found that. 2 and 0. So if this is 2, then 1 is here, somewhere here. And in this region, do you see that the straight line, k, is above the hyperbola? No, sorry, not the hyperbola, the exponential function. It's above the exponential function. So since k is above f, you're going to have to say k of x minus f of x. That's how you'll find that vertical distance, okay? Because you need to say the one that is above minus the one that is below. So I'm going to say k of x minus f of x. And let me just call this the distance. I guess I can just call it the distance. D is equal to this. And k of x, I now have the equation of it. It is 3 over 2x minus 3, 3 over 2x minus 3, minus, I know what f of x is already from the start. It was 2 to the power of x. So, but remember there's two terms. So you need to protect it with brackets. 2 to the power of x minus 4. Then when you're simplifying, we're just saying 3 over 2. We have x minus 3, and we distribute. That's negative, and 2 to the power of x. Okay, that's just the coefficient. It's not really, And so we have negative times that negative, which is positive 4. You can simplify this a bit further. So 3 over 2x. Let's put the numbers together. So we just have a minus 2 to the power of x. Positive 4 minus 3 is positive 1. Okay, so this is the expression for the distance, the vertical distance. But they specifically told us where to find it. They said where x or at x is equal to 1. So in place of this expression, the distance, I'm going to substitute 1 in place of x. So I'm saying d of, I guess I could have just called this d of x this whole time. So d of x. So I'm saying d of 1 now is equal to 3 over 2 times 1 minus 2 to the power of 1, okay, plus 1. Okay, now that all of that is in, I'm just going to go ahead and find the answer. So this is equal to, I'm just going to use the calculator, 1 over 2. And so that is it. The vertical distance is a half. Okay, so that's what we get. Now the next question, 4.5. So you see, first few questions always okay. 4.5 says we have to write down the equation of g if it is given that g of x is equal to f of x plus 4. Okay, another simple one. Just write down the equation of g given this translation that has happened. So since g of x is equal to f of x plus 4, then the equation of g of x is going to be equal to, just substitute whatever f of x is, and then you just say plus 4. So f of x, you know that was 2 to the power of x minus 4. So 2 to the power of x minus 4. Then we just put in the plus 4. As you can see, negative 4 and positive 4 would cancel. G of x is just going to be equal to 2 to the power of x. And that's our answer. Okay, moving on to the next question, 4.6. We're almost done with this question 4. So question 4 says, write down the domain of the inverse. Okay, now the reason I'm stopping here and thinking about this carefully is because of this. You see this part? Yeah, I know they didn't do this for nothing. They restricted this one. Okay, so we have to think carefully about this. Okay, so here is the thing about the domain and the range of a function. You have to think about what the original function is and then the inverse of it, right? So if this is the original function, right, and this is the inverse of the function. So we have the domain of the function, right? And we will also have the range of this function. Now, whatever the domain of this function is, it's going to become the range of the inverse. And whatever the range of the original function is going to become the domain of the inverse. Okay, that's how they work with inverse functions. So I want to think about this carefully because I know that this was a translation from the graph of f, meaning we had the graph of f and then it was translated and became the graph of g. But I noticed here that there was a restriction applied to the domain of f. So if there was a restriction applied to the domain of f, then since g is coming as a translation from f, then that restriction would also be applied to it as well. So since the graph of f of x, right, f of x being equal to 2 to the power of x minus 4, it had a domain of x is an element of ranging from 2 to 4. But remember that 2 is actually included. That's why there's a square bracket, meaning x has a value of 2, but not necessarily 4. It's just numbers that are less than 4, but not exactly equal to 4. Okay, that's why it looks like this. We have a closed circle here and an open circle, just to indicate that it's not really equal to 4, but its number is less than 4. Those are the x values we're speaking about. So since this is the domain of f, then this would also count as the domain of g. G of x is equal to 2 to the power of x. This is the domain of g, right? So in order to be able to find the domain of g's inverse, I need to know what exactly the range of g is. I know what its domain is. Its domain is this, because it's the same domain applied. It's kind of like it's a restriction. It's saying you can only draw a graph, or this graph can only exist within -2 to 4. So that graph of g, right, we know it became this. So as you can see, it shifted up. So that graph is probably like here. But either ways, it's been restricted like that. And because it's being restricted, its range will also be restricted. So we need to find what exactly the range of g is. So let me find the range of g. Since this is the domain, it's saying that it can only go from 2 to 4. Then because of this restriction, what exactly would be the range? Since our equation is g of x is equal to 2 to the power of x, I would just say to find the y values, okay, where it's going to start and where it's going to end, right? What y value it's ending at, I would just say 2 to the power of and substitute an x value in there. So 2 to the power of 2 gives me 4. And then I'll also substitute that as an x value to find out where it's ending. So that's 2 to the power of 4, which is 16. So this is ranging from 4 to 16, meaning the range of this graph is y is an element of, and I'm going to have to put a square bracket again at 4, because you see that at 2 we had a square bracket, meaning x is equal to 2. So y will also be equal to 4. So starting from 4 and ending at 16 with a curved bracket, because it's not really including the actual number 16. So if this is the range, right, of g, so now what we have is, we have the graph of g of x, which is equal to 2 to the power of x. We have its domain, because that's what it seems like they restricted it, you see. So the domain of this was the same domain as f's domain. So x is an element of from 2 to 4, and its range was y is an element of going from 4 to 16. So it means that the inverse of g, right? The inverse of g, the domain of the inverse of g is going to be whatever the range of the original was. That's how it works. So the range was this. That's going to be the domain. But of course, it's a domain. You cannot write it in terms of y. You have to write it in terms of x. So it means that the domain, right, by that rationale, because of that restriction, the domain of g is x is an element of 4 all the way to 16 and curved bracket. That's what I would say is the answer there, because of that restriction. Okay, moving on to the next question. The last question here, they want us to write down the equation of the inverse in the form of y is equal to. Okay, so the equation of the inverse, you know, the original of g looked like this, so 4.7. The original of g said g of x is equal to 2 to the power of x. So the inverse, we're just going to write this first of all as y. So it's y is equal to 2 to the power of x. Then first you're going to swap x and y. So in place of y, I'm going to put x. and 2 to the power of, in place of x, I'm going to put y. Then I'm going to make y the subject. To make y the subject, since y is an exponent, you have to use log. So y is equal to log, and we're going to put x, and the base is 2. Okay, log x base 2, and that is our answer. Okay, so that is it for question 4. And moving on to question 5. Okay, so now we're on question 5, and question 5 says this. We have the graphs. Let me actually just try to make this a little bigger, okay, just in case. So the graphs of f of x is equal to negative 1 over 2x minus 1 all squared plus 8, and g of x is equal to d over x. So you can see this is a parabola, and it's put in turning point form. And we've been given d over x. You see something over x. That is a hyperbola. Okay, it really looks like, it's very similar to the mother graph. And then we have, they are drawn below. A point of intersection of f and g is B. The turning point of f is also the turning point of f. Okay, the graph of f has intercepts at negative 3 and 0 and 5 and 0. So there we go. We have intercepts and a y-intercept at C. Remember, first questions are always very chilled. Don't panic. That last question, if it gives you too much of a headache, always just, come back to it later. So 5.1 says this. We have, write down the coordinates of the turning point of f. So remember how this is already put in turning point form, okay? It's already put in the form of a bracket x minus p all squared plus q. P and Q are your turning points. So notice that it says minus P here, but I said P, meaning whatever number you see here, if you see a negative 1, take the positive of it. You always really multiply it by a negative 1. So it means that your turning points, which is B as well, right? That is 1 and 8. So that's our turning point. Okay, moving on to the next question. The next question says, we need to calculate the coordinates of C. Well, C is the y-intercept of the parabola. How do you find the y-intercept? By doing what? By making x equal to 0. And you have to do that here because this is in turning point form. It's not in standard form where you can easily see the y-intercept as C. So this is going to be, we have f of, well, let me just write it here. F of 0 is equal to negative 1 over 2, 0 minus 1 all squared, plus 8. And you can just substitute that all into the calculator, and that's going to be your answer. And I get 15 over 2. Okay, so that is C as a coordinate is going to be, the x value is 0, and the y value is 15 over 2. So there we go, we have that. That's 15 over 2. Okay. Then the next question is calculate the value of d. So d is from g of x, d over x. Let's think about how we can calculate the value of d. Remember, it's just d over x, meaning if you have a point, you can substitute it in place of x and y, and then d will be remaining and you'll be able to solve for d. So we just need to find at least one point that lies on that graph of g, the hyperbola. Do we have a point that lies on it? Yes, we have B. B is the point of intersection between the parabola and the hyperbola, okay? And the coordinates of that was 1 and 8. We already had that. So I can find this by saying g of x is equal to, we have d over x, and we're just going to substitute. The x value is 1 and the y value is 8. So 8 is equal to d over 1. D divided by 1 is d, so d is equal to 8. Okay, so that's our answer. D is actually equal to 8. Moving on to the next question. The next question, 5.4, says write down the range of g. So do you see that g is a hyperbola? Hyperbolas work like this. Their range, okay, and the domain, very similar. They have basically every number on the number line, okay? They will have every single number on the number line. The only number they will not have is whatever their asymptote is, because they're asking for the range. Remember, the range is all the possible y values of the graph. So look, you see it has every single y value. The only y value it will not have is whatever its asymptote is. So you just have to think about what that horizontal asymptote, okay, because that's going to be a y value, one of the y values that it will not have. It will not have a y value of that. So what exactly is the horizontal asymptote of this graph? Well, the graph is really just g of x is equal to 8 over x. To find the horizontal asymptote, remember that this graph is actually supposed to be in the form of a over x minus p plus q. This is going to be a horizontal asymptote. And since we can see we don't have a plus q anywhere, it means that the value of q is 0. So we now know what that y value is. It's 0. So to find the range of this graph, the range of this graph is simply just y is everything. So it's an element of real numbers. But y cannot be equal to whatever the value of your horizontal asymptote is, which is 0. And that's your range. Okay, moving on to the next question. The next question, 5.5, says we have to, for which values of x will f of x multiplied by g of x be less than or equal to 0? So f of x multiplied by g of x be less than or equal to 0. Let's think about how this can actually possibly ever happen. If you're multiplying two things and they give you something that is less than 0, it means they give you something that is negative. The only ways that this can happen is if this is positive and this is negative, or if this is negative and this is positive. So what we're focusing on here is where on the graph do we have f and g having y values that are both positive and negative at the same time. Okay, so let's look at our graphs and see where that happens. Okay, so we can look at this side by side. Let's start off right at the edge. See here, right? If we look right at the edge here, I'm always going to look at it like this. So I'm saying that this has a y value here, somewhere here. You see this? Its y value, okay, of the graph of g is negative. It has a negative y value. And this one, the graph of f, also has a negative y value. That's a bad combination. That will not give us a negative. We're looking for where it's positive and negative at the same time. Okay, so that's not going to work. And you see that if we keep going all through here, it doesn't work because they're both just negative the whole time until we get here. Okay, at -3. And I'm specifically pointing at -3 because at -3, the parabola has a y value of 0. So its y value is 0. What is the y value of g? You have to make sure you align it vertically like that. So this will be for the same x value. The y value of g here is a negative value. The y value of f here is 0. 0 times a negative value gives you 0. That's one of the things we're looking for. When you multiply them, they must either be negative or equal to 0. So at -3, this is working. Okay, let's keep moving. We're moving towards the right. So we know that -3 is working. If you continue moving, like let's say I draw another vertical line here and look at the y values of these points. So here, this has a positive y value. This one at that same x value has a negative y value. This is a good combination. Positive times negative would give you negative. So this is working all through here. So it's still working here. Starts from here. Starts working. It's still working here. Okay, for the same x values, of course. And it's still working here. But the thing about it is I can't actually say it's working here anymore. The reason why is because we're going to have an asymptote here once we reach the y-axis. Okay, that's where our asymptote is, one of the asymptotes, because the graph of g says 8 over x. Remember that the original function of a hyperbola is supposed to look like this, a over x minus p plus q. So what exactly is that p value? It's also 0. So it means its vertical asymptote is also 0. So we have an asymptote here, and that's why I say I can't really pass here. So I can see now that this is working, right? From values that are greater than or equal to -3, but less than 0, I cannot include 0. So that's the first thing I'm seeing. I'm seeing places where f is positive and g is negative. That one worked out. This happened where x was greater than -3, but less than 0. Okay, so that's the first part I find. Let me find another part. I use a different color this time. Okay, so now let's just keep going. After this 0, you see that the parabola has positive values. It still has positive y values. Positive y value, a positive y value. And the hyperbola is also having positive y values. We don't want that. We don't want this situation where the y values are both positive, because if you take a positive times a positive, it will just give you a positive, not a negative, okay? So we cannot take that. So if we keep going through here, they both have positive y values, and we don't want that. We keep going here, they still have positive y values until 5. At 5, the graph, this parabola f, has a y value of 0, okay? So it has a y value of 0. And let's look at the graph of g for the same x value. So if we're looking at it for the same x value, this has a positive y value. But that's not a problem, because this has a y value of 0. So it means that if you take that 0 times whatever that is, you still get 0. And that's what one of the things we're looking for. We're looking for when you take f times g, they give you 0 or something less than 0. So I say that, okay, 5 is a point that I need to remember to take, to include. It's a part of our solution. And then we keep on moving towards the right? And then you see that here, this has a positive y value, and this has a negative y value. We want positive times negative. So positive times negative is negative. So it's working all through here. And you see that here again, still has a positive y value. And for that same x value, it's a negative. So I can see that it's working all through here as well. So starting from the 5, like that, and for the same x value like that. And it will keep working, because as you can see, this parabola is shooting down, and this one is just going to go closer and closer to this x-axis, but it will never touch it, meaning it will continue to have positive y values even though it's getting closer to this x-axis. So see, it has a positive. It will still have a positive y value, okay? No matter how close it gets, it will still be positive. So the solution here can be that I have to include 5, but I can see that it's values that are going this way, which are values that are greater than 5. So here I can say, or x is greater than or equal to, because I have to include 5, okay? Because at 5, that has a y value of 0. 0 times that is 0, which is what we are also looking for. So you see that that works out. I don't know, did I write? I think I might have erased that. So I meant positive there. Okay, so that would be the two places where if you multiply them, they give you a value less than or equal to 0. Okay, so that is that question done, 5.5. And we move on to the next question, 5.6. Okay, so 5.6 says we need to calculate the values of k so that h of x, which is equal to negative 2x plus k, will not intersect the graph of g. So this must not intersect the graph of g. Well, when you're thinking about things not intersecting, for you to actually be able to think about that, you're going to have to think about what it means for two graphs to intersect. When two graphs intersect, it means that they have the same x and y value at that point of intersection. So if we want to find out where h will not intersect the graph of g, how about we find out where they will? How about we make them intersect first, then we can manipulate that equation to then find out where they will not intersect. Okay, so here, this is what we have. H of x is equal to negative 2x plus k, and we already know what g of x is. Well, g of x, they already told us that was 8 over x, so it's 8 over x. I'm going to go ahead and equate these, because they want us to find out just the values of k for which they will not intersect. In other words, what must k be for these two graphs to not intersect? So I'm going to make them intersect first. I'm going to equate them. Make h of x be equal to g of x. Then I'll tamper with that equation so that I can make them not intersect using delta. Okay, so I'm going to say negative 2x plus k is equal to 8 over x. This will be the values of k for which they will. Well, it's not going to be the values of k. This is just saying that they do intersect. then I'm just going to have to simplify this a little further. Okay, so to simplify this, the issue that I see here is we have x on the denominator, and so it needs to be on the numerator. Okay, so since it needs to be on the numerator, we can get rid of this x by multiplying both hand sides by x. Okay, so if you FOIL in, this is what you get. You have negative 2x plus kx. I'm going to call it kx on purpose. Okay, because it's the coefficient of x. And this is equal to, this cancels and you have 8. So now do you see that this is, negative 2x squared, okay, x times x. Now do you see that this is a trinomial that it has just formed? So I can rewrite this trinomial as negative 2x squared. We have plus kx, and then minus 8 is equal to 0. This would be an equation for which these two intersect. This would be the equation when you equate them to those two graphs. But we need to make sure that they don't intersect. And we're going to do this using delta. Okay, so we just need to find the values of k for which they will not intersect. So you see, delta can be various things. If delta is greater than 0, the kind of roots that you're going to have, first of all, are going to be real, right? Meaning you're actually going to have intersections, right? So if you're going to get roots that are real and will probably be unequal as well. If delta is equal to 0, your roots will also still be real, but they will be equal, okay? Real and equal really just means it's the same number, like x minus 3 and x minus 3, right? And then if delta is less than 0, your roots will just be non-real. In other words, they don't even exist, meaning that parabola that you form doesn't have roots. In other words, it doesn't even intersect that x-axis. It may be just way above the x-axis, or it depends on the shape of it. If it's like that, it doesn't even touch. So that's what we're going to do. We're going to manipulate this equation. We're going to find out the values of k for which they will not intersect. In other words, the roots will not be real. In other words, the roots will not exist. So I'm trying to find out where delta is going to be less than 0 for this equation. And so delta is b squared minus 4ac. I need to make that less than 0. So how do we make delta less than 0? Well, we're just going to substitute what delta is. B squared, well, our b value right now is this k, because this is in the form of ax squared plus bx plus c. You see now that your k is b. So in place of b, I'm going to say k, and I have to square that. Minus 4, and then a is negative 2, and c is negative 8. And this is equal to 0. Okay, so this is what we have. I have k squared, and what is negative 4 times negative 2? That is going to be positive 8. Then if you multiply that by negative 8, that is 8 times 8 is 16. So negative 60, 8 times 8 is 64. Negative 64 is equal to 0. Okay, sorry, why am I saying equal to 0? Less than 0. Less than 0. Okay, so I just have to solve for k in this inequality, really, because this will help this equation to not be equal. In other words, to not intersect. So this would be the values of k for which this will not intersect. H and g will not intersect. So let's simplify this. This is an inequality. I can look at this as difference of two squares. So open up two brackets. The square root of k squared is k, so k times k. Square root of 64 is 8, so I'll say plus 8 minus 8. So my critical values are negative 8 and 8. And I just have to solve. Now here I'm just going to use the graph method. I know earlier in the video I used the, table method. That was quicker. But I'm just going to use the graph method. So here I'm just going to look at the shape of my graph. K squared minus 64 is a parabola. It's a positive or concave up parabola. And I have my critical values of negative 8 and positive 8. And I'm looking for the places where the y value is less than 0. Again, you can look at my other papers. I do explain in more detail there. Okay, so where are the y values less than 0? Well, the y values will be less than 0 here. So we're not going to look at anything above the x-axis. You're going to look at all the parts that are below the x-axis, which is all through here. And so the x values belonging to this highlighted part would be x values that are greater than -8, but less than 8. Okay, that's the highlighted part's x values. And so what I'm saying is that k has to be greater than -8, but less than 8. And that would be the values of k for which h and g will not intersect. You see, you make them equal to each other, kind of like making them intersect. They will form an equation in standard form, and then you manipulate that equation. You find out the values of k rather, for which they will not have real roots, because when they don't have real roots, they don't intersect. Okay, moving on to the next and the last question for question 5. Okay, so question 5's last question is this. We are told that h is a tangent to g at r, a point in the first quadrant. So, okay. And then they also tell us to calculate t such that y is equal to f of x plus t intersects g at r. Okay, that's a mouthful. Let's think about that. Okay, let's break that down. So h is a tangent, right, to g at r. And they told us that that point r is in the first quadrant. Let's think about what g looks like. G looks like this, and they're saying that h is a tangent to g. So you have something like this. You have a tangent to g, right? A line that only touches g once. And this tangent to g, okay, its point of intersection is this point called r, which is in the first quadrant that they said. So this is h, this is g. Let's just keep that in mind. Okay. What else do they say? They say that calculate t such that y is equal to f of x plus t intersects at r. So we have this new equation or graph. It's called y is equal to f of x. So it includes that parabola plus t. We need to find the values of t for which it's actually going to intersect at r. Okay, so what's actually going on here is you have some sort of, we have this situation where we have h, we have g, but we also have a new graph, a parabola, which is formed by taking the graph of f and translating it somehow up or down. It's one of the two, right? So we have that. It's still an upside down parabola. Still the same thing, really. Okay, something like that, but it's intersecting at r as well. And we just need to find out the values of t for which it's actually going to intersect r. Okay, so in order to find out that, so to find t, we can think about it like this. If you can find the coordinates of r, the x and the y value of r, then in that equation of y is equal to f of x plus t, right? Since this is the point of intersection, then we could have just taken that. We can just take that and substitute it into this equation because that's the point that it intersects. We need to find out for which values, for what is the value of t that would help make r a point of intersection of this graph, this new graph. So when we find r, we can just take that and substitute it into this equation and we will be able to find t. So the goal here is find r. Okay, how do we find r with the information that we have so long? Well, they told us that h is a tangent to r, okay? To g at r, sorry. H is a tangent to g at r. Let's also just write down the things that we do know. A g of x, right, it has an equation so that we just see that it's not like there's no equations here. That's 8 over x. And h of x also has an equation. It's the equation that they just spoke about in this previous question. So h of x is equal to negative 2x plus k. Let's also keep that in mind. Negative 2x plus k. Because they said h is a tangent to g, what you should know about tangents to graphs is that at that point of intersection, okay, at that point of tangency, you know that the gradient of that graph and the gradient of the tangent are exactly the same. And that is actually a very powerful fact that we can use to even find the point of intersection. We can use that to find r. So how we can find r is because the gradient of g, in other words, g prime of x, should be equal to the gradient of h prime of x. And the great thing I'm seeing here is h is a straight line. And we can clearly see the gradient. Look at the gradient. It's -2. So we have that, right? We know that's -2. We just have to find the gradient of g. You know g of x is equal to 8 over x. So how about we find g prime of x, which is the gradient of g. So g of x is equal to, and I feel like I should have done this second. Okay, so I'm just going to put it down. So g of x is equal to 8 over x. Let me prepare it to be derived, because right now the x is on the denominator. It needs to come to the numerator so that you can derive. So it's equal to 8x. But when you move it to the numerator, its exponent becomes negative. So to the power of -1. Now I can derive it. So g prime of x is equal to, I'm going to say coefficient times exponent, -8. X to the power of exponent -1. -1 minus 1 is -2. So this is g prime of x. We have that. And so what I'm saying is I'm going to make g prime of x, the gradient of g, equal to the gradient of h. So that is -8x to the power of -2 should be equal to the gradient of h, which is -2. If you like, you could have derived it. The k would have still fallen away because it's just a constant. So -2. And now we just have to solve for x. You see, the x value here will tell you the x value of the point of intersection between that graph of g and your tangent h. So I'm going to say -8, and I don't like that this is negative, so I'm going to move it over to the denominator so that it can become positive. It becomes x squared is equal to -2. I shouldn't have done that there. Okay, let me get rid of this negative first. So I can get rid of the -8 to leave x alone. Divide both sides by -8, and so I have x raised to the power of -2 is equal to, what is -2 divided by -8? That is 2 over 8, 1 over 4. Okay, so at this point, I'm just going to put this in a way that its exponent is positive. So to do that, I'm going to have to change this to 1 over x squared, because I'm really just taking this, it's naturally on the numerator, and I'm moving it to the denominator so that its exponent can become positive. This is equal to 1 over 4, okay? So since it's equal to 1 over 4, to solve for x, if you like, you can cross multiply, okay? X squared times 1 is x squared, and 1 times 4 is 4. So x squared equals 4. Solve for x. If you square root both sides, you're going to have to say plus minus. X is equal to positive or -2. But they told us that r is in the first quadrant. So x is equal to +2. So there, we got the x value of r. Now we just have to find the y value. Okay, so the logic behind it is already figured out. We just have to apply it. So y, how do you find y? Well, it is the point of intersection of h and g. I don't have the complete h of x, but I do have the complete g of x. So I'll just substitute it into g. So g of, and I'm substituting the value 2 because I know that's the x value now, is equal to 8 over 2. And so g of 2 is equal to 4. And so now that I have that, I can just go ahead and say that g of 2 is equal to 4. And finally, this means that r is the point 2 and 4. Great, we have r. Now that we have r, we can finally find t, what they're asking for. You see, the equation is y is equal to f of x plus t. And we just need to find out what exactly is t, right? What should t be for this to intersect r, to pass through r? Well, we're going to take r and substitute it into here, saying that it's a point, right, on this. And then we'll find out exactly what t must be for this to actually happen, for it to intersect with r. So this is x and this is our y value. So I'm going to say 4 is equal to, no, let me expand this first. So y is equal to f of x is -1 over 2 bracket x minus 1 all squared plus 8. Then I still have plus t, right? I'm trying to solve for t. So now I can substitute x and y. So our y value is 4 is equal to -1 over 2. And then the x value is just 2 minus 1 all squared. And we have plus 8 plus t. Okay, great. I see numbers all through. So I see numbers all through here. I'll just simplify that and find out what that is going to be. And there I get 15 over 2 plus t. And this is 4. And then I'm just going to take 15 over 2 over 4 minus 15 over 2. You can use a calculator, but I can also express 4 as 8 over 2. So the denominators are the same. 8 minus 15 is negative 7. Negative 7. Okay, so negative 7 is equal to, we still have t there. And so this is now negative 7 over 2, because 8 minus 15 is negative 7 and the denominators stay the same. So there, that's the value of t. T needs to be negative 7 over 2 for this new graph to pass through R, okay, if given that H is a tangent to G. Okay, so that is that. That's the last question, yeah. So that is the last question for question 5, and that is it for functions. And we finally move on to question 6, financial maths. Okay, so now we are on question 6. Question 6 is on financial maths. So 6.1, of course, but 6.1 says Patrick deposits an amount of deposits an amount of 18,500 into an account earning R% interest per annum compounded monthly. After 6 months, his balance was 19,319 rand and 48 cents. So the first question is we need to find the value of R. Okay, so just look at that question and ask yourself, was that compound interest growth? Was it decay? What was it? His compound interest growth, because he deposited money, right? Deposited, that's a P value, starting value, and his balance is now way bigger. So the money grew. He deposited, it's growing. So what we're going to do is we're just going to use, I like to use this acronym, PAIN, PAIN, just so that everything is sorted out already. P is our principal amount, is 18,500. 500. A is 19,319.48. The interest is what we don't know. We need to find that rate. And N is just the number of payments. Well, it's 6 months, so we can just say 6, and we don't have to multiply by 12 because it's already in months. Now, with that being said, I have to explain what we're going to do here. By the I, you need to remember that whatever the interest is, we need to put that over 12, okay, because it is compounded monthly. I'm just not going to multiply that by 12 because it's already in months, 6 months. So this is what we're going to have. We have A is equal to P bracket 1 plus I raised to the power of N. So the A is the 19,319 rand and 48 cents. And then we have, it's equal to, okay, so I'll just put it on the side there. So I'm saying this amount, to just substitute everything in. A, which is this, is equal to the P value 18,500 multiplied by 1 plus I, and our interest is just I, over 12 raised to the power of 6. And we just have to solve for I, and then of course put it as a rate, not just as a decimal. Okay, let's go ahead and do that. So in this equation, how do we get I on its own? Well, the first problem that we have is this 18,500. It's the first thing blocking us from getting to the I. So we need to divide both sides by 18,500, but I'm not going to find the answer because I don't like working with decimals. So 18,500, I'll leave it like that. So here this cancels, and here I'm just going to rewrite this, really copy and paste, exactly as it is, like that. And I have here, since that cancelled out, it's equal to 1 plus the interest over 12 raised to the power of 6. Okay, now what's your next problem? What is stopping you from getting to this I? It's the 6. So we're going to find the 6th root of both sides. Okay, this is financial math. Interest is never negative. You don't have to think about positive and negative. So when that happens, what happens here is the they cancel each other because they're the inverse of each other. And this is, I'm just going to leave it like that. I don't want to work with decimals, so leaving it like that. Okay, so this is what we have right now. And then we still have here, when that breaks open, we have 1 plus the interest over 12. Okay, and then now that we have the interest over 12, we're just going to say, take the 1 over now, because that's what's stopping you from getting to the I. And so we're just going to have this exact same thing, but the 1 is coming over and becoming a minus 1 is equal to I over 12. Lastly, the 12 is in the way. We have to get rid of it. Since it's saying divided by 12, you would multiply by 12 to get rid of it on both sides. Okay, so our interest is equal to all of this, 12 multiplied by the 6th root of that 19,000 and all of that. Okay, and when you substitute that onto the calculator, the interest I get is I is equal to 0.087000, and this just keeps going. But then remember, you need to answer them as a rate. When they ask the question as a rate, they want like 12% or 3.5%. So you need to multiply it by 100. So take all of that and just multiply by 100, and that's going to be your percentage. Your rate, right, or R, is 8.7% because you just have zeros all through there. So that is your rate. Okay, so that is the first question. And the next question is this. 6.1.2, calculate the effective interest rate. So nominal and effective interest rate. The nominal interest rate is really the interest rate that the bank quotes you with whatever compounding that you have. And then the effective interest rate is that converted into kind of a yearly interest rate. It's just converted into a yearly interest rate. And so the effective interest rate is, that formula works like this. You say 1 plus I effective is equal to 1 plus I nominal divided by, I guess you can say n to the power of n. Okay, so whatever compounding that we have, we'll put that there. And so we'll find the effective interest rate. In this one, it is 1 plus, we have I effective, and this is equal to 1 plus the nominal interest rate is whatever was in a different compounding. In this one, it was this interest rate that we found 8.7%, but you have to put it as a decimal. So we will put it as 8.7%, right? Over whatever compounding it was in. It was compounded monthly, so we have to put it over 12 raised to the power of what? 12. Okay, this is not considering any 6 months. We're just working with the actual interest rate and converting it into an effective. Okay, so I'm used to putting brackets here. It's not really necessary because, okay, it's raised to the power of 1 really. And so now to find that effective interest rate, you see that the 1 is in the way, so you need to take it over. So it really just means that I effective is equal to everything that we still had here, and all that happens is that 1 is going to come over and become a minus 1, and that's going to give you your effective interest rate. Okay, so this is what I get. I get 0.09055, but then I'm just going to turn it into a rate by multiplying it by 100. And so my effective or yearly interest rate is actually just going to be times 100. It's just 9.055, which if you round off to 2 decimal places is 0.6. Okay, because it rounds up. That 5 is going to round up. So 9.06%, and this is a yearly interest rate. Okay, so that is 6.1 done. And now we move on to the next part. Okay, so the next part says this. I probably need to just make the screen a little bigger. Okay, so it says, Kuda bought a laptop for 10,000 Rand on the 31st of January 2019. He will replace it with a new one in 5 years' time on the 31st of January 2024. So this is 5 years exactly. It's 31st of January 2019 to 2024. That's exactly 5 years. And we have the value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. After how much years will the laptop have a value of 0? As you can see, something is depreciating, but it's depreciating on a straight line method. So what is the formula for a straight line depreciation? It is A is equal to P bracket 1 minus I multiplied by N. Okay, because this is straight line, it's not compound, and it's also depreciating. So we just need to know what all these values are. First of all, P is always the starting value, whatever you start off with. Okay, P is not just always, whatever is the smallest number. No. Okay, it's whatever you start off with. Whether it's going to be the smaller or the bigger number depends on whether you are depreciating or this is an investment, something that will appreciate. Okay, so what we're just going to do is the value of P is going to be whatever money he starts off with. So Kuda starts off with 10,000 Rand. That's what the laptop costs at first. So that's going to be P. So that's what I'm putting in place of P, 10,000 Rand, right? And then after 5 years, so we also know what N is. Really, we also know what R is, okay? And we know what A is as well. They said the laptop is going to have a value of 0 Rand. That's how much he ends up with. So the starting value is 10,000, but the ending value is 0 Rands. Okay, so we have 1 minus the interest is 20% on a straight line method, so it's not compounded. So 0.20, then multiplied by N. Okay, it's multiplied by N because the question is how many years? Okay, so we need to find out the time period. So multiplied by N, and I'll just say times N like that. So we just have to solve for N in this straight line equation. It's a linear equation. How do you get to N? Well, first you have to get rid of the 10,000, and you can get rid of it by dividing both sides by 10,000 Rand. If you divide by 10,000, 0 divided by 10,000 is 0, and so that cancels, and you're left with 1 minus 0.20 N. Then I need to solve for N, so I'm going to rather take this over to this side since it's negative, so it becomes positive 0.20 N is equal to, and I still have the 1. Then I need to solve for N. So to solve for N, I'm just going to divide both sides by 0.20. And so N is finally equal to whatever 1 divided by 0.20 is. And 1 divided by 0.20 is just 5. So how much years is it going to take to become nothing? 5 years. Okay, so that is that question. Moving on to the next question. Okay, so 6.2.2 says, Kuda will buy a laptop that costs 20,000 Rand. In order to cover the cost price, he made his first monthly deposit into a savings account on the 28th of February 2019. He will make his 60th monthly deposit on the 31st of January 2024. The savings account pays interest at 8.7% per annum compounded monthly, okay? And they also say that calculate Kuda's monthly deposit into this account. So, with the way everything looks, they're really not trying to complicate things. They're actually being very straightforward with this question. They're even saying 60th monthly deposit, telling you already how much deposits we're going to have. So because Kuda is trying to save money, and we can see that he's trying to buy a laptop that costs 20,000 Rand, anytime you're working with a savings plan, this is going to be future value. Okay, so Kuda is saving money. So the future value formula says it's future value is equal to X, and then open bracket, bracket 1 plus I raised to the power of N minus 1, close bracket over I. The future value, let's think about what that is. That's the amount that he's supposed to have in future. Does he have the 20,000 now? No, that's how much the laptop costs. That's how much he wants to end up with in future. So that's your cost. That's your future value, 20,000 Rand. Then the X, do we have that? Do we know how much Kuda is going to pay monthly? No, because they asked us to calculate Kuda's monthly deposit. That's going to be X, okay? Kuda's monthly deposit is X. So we're leaving x open, and then open bracket 1 plus the interest rate is 8.7% per annum compounded monthly. So you need to put that in decimal form, 0.087 over 12 raised to the power of how much deposits. N is always for the amount of deposits. Well, you see, they already told you the 60th monthly deposit. He will make his 60th monthly deposit on this day. That's the last deposit. So the deposit is 60 deposits minus 1, and then all over that same interest, so 0.087 over 12. And now we just have to solve for x. So this is a common one where you have to solve for x because it's the monthly deposit. A way that you can do this is, imagine all of this is just one single number and you have x next to it. In order to solve for x, you would just say simply all of this divided by that number that is there. And what you do on this side, you must do on this side. So you would say 20,000 divided by that number that is there. Okay? So your equation will just say x is equal to 20,000 divided by everything here. Okay? So it will look like this. And this will finally be equal to 267 Rand and 26 cents. That's how much his monthly deposits will be, so that he can end up with that 20,000 after 5 years. Okay, so that is it for that question. Then we move on to the last question in question 6, which is 6.3. So question 6.3 says, Tino wins a jackpot of 1,600,000 Rand. So that's how much he wins. He invests all his winnings in a fund that earns an interest of 11.2% per annum compounded monthly, and then he withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. That's normal. And so the question is, how many withdrawals of 20,000 Rand will Tino be able to make from this fund? So now do you see what's going on? Money keeps leaving. It's still a loan. The only difference is that Tino is not loaning from the bank. The bank is basically loaning from Tino because he's given them his money and he's going to be receiving from them 20,000 Rand just because of the interest that is applied to that loan. Okay, so this is the situation. This is one of those situations where a person is borrowing to the bank. Okay, the people who invest money, it's kind of like borrowing to the bank. You're giving the bank your money for a period of time. It earns interest, and sometimes you can actually just ask them to give you a specific monthly amount. Okay, so a monthly withdrawal really. Okay, so it's still a loan, just not Tino. Tino is not loaning from the bank. It's the other way around really. And so we need to find out how much withdrawals of 20,000 Rand can Tino receive. That's a very important question to really focus on. How much withdrawals? They're not saying how long will it take his money to finish. How much withdrawals? So let's think about what present value looks like. The present value formula is x bracket 1 minus 1 plus I raised to the power of negative n, close bracket, over I. Okay, so this is what we have. The present value, the money that the bank currently will owe Tino if he gives them the money, if he invests the money, is that 1,600,000 Rand. Then the X value is really the amounts that Tino is going to allow to withdraw every month, which is 20,000 Rand, right? Then the interest is compounded monthly, 0.112, so that's 11% over 12. And then finally, we also know now we need to find N. So you see N always stands for the number of years. If you don't touch N, if you don't do anything to N, it will just give you the number of installments, right? It's going to tell you how much installments were made. So you leave it like that. Don't touch it. Just leave it like that. We're not going to divide. So I will leave N like this and just simplify this. Okay, so we're just going to have 1,600,000 is equal to, and the X value is 20,000 Rand, open bracket 1 minus 1 plus 0, 11, 2 over 12, raised to the power of negative how much? We don't know that yet. So negative n, close bracket. And then we have all over that interest, which is 0.11 over 12. Must be careful. Okay, so when we are at this point, we just need to find a way to get to the n, or the negative n really. So we can get to it, first of all, by getting rid of things that are stopping us from getting to the n. The first thing I see that is stopping us is this. Okay, so since this entire expression is being divided by this, to get rid of it, I can just multiply both sides by it, 0.112 over 12, and do the same on this side, 0.112 over 12, right? And now this is gone on this side, and what I will be left with here is I'll just calculate that. It will probably be a fraction. And as a fraction, what I got was 44800 over 3, right? For that part. But now this is now gone. All I have left here is the 20,000 still being multiplied by 1 minus 1 plus. Now, because this is a fraction, this gives me an opportunity to just find out exactly what this is. So I want to find out what 1 plus 0.112 over 12 is, and keep that answer as a fraction. That's what I'm just trying to do here. So let me see what that gives us. So as a fraction, that is equal to this. So it is 757 over 750 raised to the power of negative n, and close the bracket. Okay, so there's nothing we're dividing by now. Now the next problem, stopping us from getting to that negative n, would be the 20,000. So you'd have to divide both sides of the equation by 20,000. So divide by 20,000. Okay, so this number divided by 20,000. I suggest you actually use the division button. So like that, over 3, then say divided by that 20,000. Okay, also gives us a fraction. That's good. So we're just going to use it as fractions because it's easier to keep track of what it is rather than decimals. So it's equal to, and this cancels now, and you're left with 1 minus 757 over 750 raised to the power of negative n. Then I can take the 1 over. So in other words, I have this answer, and 1 is coming over, becomes minus 1. And now this is what I have. I have negative 19 over 75 is equal to, you see, you still have a negative here in front of this. And we have 757 over 750 to the power of negative n. Okay, they're both negative. You can get rid of the negative by multiplying both sides by negative 1. Okay, and that will cancel out the negative. So I'm just going to say it as I'm canceling out the negative. Not that it wasn't there, it was there, but I'm just canceling out. Okay, so gone. And of course, I would just take this and still multiply it by negative 1 so that it is positive. And I am using the positive number now. Okay, so since now what we have is 19 over 75 is equal to this over to the power of negative n. We need to solve for negative n. So to solve for an exponent, you have to use log. So I'm saying negative n is equal to log, and I'm going to write down my base. My base is whatever is carrying the exponent, which is this. So my base is 757 over 750, and then the number that it's equal to is the number I write here, 19 over 75. Okay, so these are all nice looking numbers that I can use. So I'm just going to use them like that. So on the calculator, go to log, right, with the one with the base, and you're saying 757 over 750, and then here you're going to put your 19 over 75, and this is what it gives us. Negative n is equal to negative 147.7978, and this keeps going. I'm just going to go ahead and divide both sides by negative 1, or you can say multiply by negative 1 on both sides. And so I'm saying that n, positive n, is equal to, so times negative 1, of course, is just going to be a positive of whatever you had before. So positive 147.7978. Now let's go back to the question so we know exactly what to tell them. The question was, right, how many withdrawals of 20,000 will Tino be able to make from this fund? This is telling you the amount of withdrawals. This was compounded monthly, okay? So this is the amount of months in total. In other words, the amount of withdrawals that is going to make. I'm not going to convert it into years. I'm going to leave it like this. But if you have to think about it, the total amount of 20,000 that he's going to be able to withdraw is 147. You cannot round off to 148 in this one, because 148 would mean that he can make a complete 148 withdrawals of 20,000, but we know he can't. He can only make 147. This is not a complete 20,000 that he would make. It's a 0.79. It's almost 20,000, but it's not exactly. So how much withdrawals of 20,000? He will make 147 withdrawals. Okay, so that's going to be our answer there. Okay, so that is the end of question 6, and then we move on to question 7. Okay, so now we're on question 7, and question 7.1 says, determine f prime of x from first principles if we have f of x being equal to negative 4x squared. Okay, so this is a place that you can really score marks. You just have to make sure that you're very careful. So we need to determine f prime of x. First, find f of x plus h so that you have that out. Let me also just rewrite f of x so I don't get confused. So f of x is equal to negative 4x squared. And so f of x plus h would just be negative 4. And wherever you see x, replace it with x plus h. So x plus h all squared. Okay, then we're just going to simplify this. So the negative 4 stays. We need to FOIL this out. Again, you can open up 2 brackets and write x plus h and x plus h. Or you could deal with this the quick way. So I square the first term, x squared. Then I multiply the first and the second term, which is xh, and then I multiply that by 2, which is positive 2xh. And then lastly, we say h all squared, which gives you positive h squared. Okay, so that's what we have. Then that is going to be, we're going to distribute this. So when it multiplies in, negative 4x squared, negative 8xh, and negative 4h squared. Okay, so now we have f of x plus h. And now we can go ahead and derive from first principles. So we're saying that f prime of x is equal to the limit as h tends towards 0. And then you're going to say the formula is f of x plus h minus f of x all over h. Let's go ahead and substitute. So lim as h approaches 0, then we have f of x plus h, which is negative 4x squared minus 8xh minus 4h squared. Then we're saying minus. Now, okay, I will still just include this part, but you will just notice that whatever f of x is, the signs that you have there will just change. But it's okay, I'll just work it out just in case there's a mark allocation for actually substituting like that. So minus, but you see that what we are minusing by has one term but a negative in front of it, so you need to put brackets still. So negative 4x squared all over, and then we'll put in that all over h. And this is equal to the limit as h tends towards 0, and we have negative 4x squared minus 8xh minus 4h squared. Then we're going to FOIL that in, so or distribute it. That is positive 4x squared. Okay, and this is going to go all over h. Now, you will notice that you see whatever you subtracted by, that's what's going to cancel here. So you're just going to have to look for what looks like this, the 4x squared, right? And you can see there we have that. This is negative 4x squared, and it's going to cancel, of course, with that positive 4x squared. So those two cancel. And then let's just rewrite what we have. So I'm writing this, I'm really just looking at this based on, the past papers, and we have all seen they usually had some steps that you should not skip where you are getting marks for. One of the steps was this part. I always used to just ignore that and take out the common factor already. Okay, so I still have to write lim as h approaches 0. Then you see that we want this to come out of that denominator, so it's not undefined. So we're going to take out a common factor of h. So h comes out, and we have negative 8x, then minus 4h. That's what's going to be left on top. And we're dividing by h. Then these two cancel. So I'm just going to rewrite it. So I'll still write the lim. Okay. And then we have negative x 8x minus 4h. Now we can go ahead and substitute. So now we're substituting. We don't have to write the limit as h approaches 0. So negative 8x minus 4, open bracket, and in place of h we'll put in 0 because it's approaching 0. Okay, so the gradient is going to be negative 8x, and that is the gradient of that function that we had originally. Okay, just to make sure that you are correct, you can go ahead and derive this using the power rule so that you see that you have actually derived that properly. Okay, so power rule, negative 4 times 2, negative 8. And as you can see, that is exactly what we have here. Okay, so you can just make sure you do that. The next question we have is 7.2. So 7.2, this is what we have. In 7.2, we have 7.2.1. You have to determine f prime of x if f of x is equal to 2x cubed minus 3x. So this is just from the rule, and this is a simple one, no complicated things. We're just going to derive that. So let me just go ahead and say f prime of x is equal to, so I'm going to say the 2 times the 3, which is 6, and we have x. Then you're going to take the 3 and subtract the 1 from it, which is 2. Then we have a coefficient of negative 3 multiplied by the exponent of an invisible 1, okay, which gives you still negative 3. Then you have x. Now you're going to take that exponent that you had there, which was 1, and you need to subtract a 1 from that. If you subtract a 1, you're going to get 0. But then anything to the power of 0 is equal to 1. And if you have negative 3 times 1, it just stays negative 3. Okay, so this is f prime of x. Okay, moving on to the next one. In the next one, this is what we have. We have dx, and I'm just going to rewrite this one. We have 7, the cube root of x squared, plus 2x raised to the power of negative 5. So it's nice that they already put that in a form that you don't have to move it yourself, because normally it should have been on the denominator. Then you would have to actually push it up to the numerator. But they've already done that for you. So it's only the surd that we need to look at. Okay, so with the surd, how to simplify a surd, or really how to write a surd with a rational exponent, is like this. We're still going to write dx because we have not derived yet. Okay, and I'm not really supposed to write equal to because you only write equal to when you are deriving. Right now I'm not deriving. I'm just trying to put it in a form that will help me to be able to derive this. Okay, so we just still have dx, and then this is what we're going to do here. You see this 3, right? That belongs to your x, that whole surd. If you want to write a surd in its standard form, but let's just put down the 7 first. So we still have the 7. Now we need to write this in a way that its exponent is rational, not really a standard form. So this is what we're going to say. We'll leave the x, and then you're going to say the inside exponent divided by the outside exponent. Okay, it's just in over out. Okay, then moving on, we have plus 2x raised to the power of negative 5. And now everything is perfect and ready to be derived. Now we can just say is equal to. And so you're saying coefficient times exponent. So what is 7 multiplied by 2 over 3? You can use a calculator if you want to. 7 times 2 is 14, so 14 over 3. 14 over 3, and we have x. And then you're going to take from this exponent and you subtract 1 from it. So what's 2 over 3 minus 1? Well, it's like saying minus 3 over 3, but you can use a calculator. 2 minus 3 is negative 1 over 3. Okay, denominator stays the same because we're subtracting. Then we have positive 2 multiplied by negative 5, which is negative 10x. Then your exponent is negative 5. You're going to subtract a 1 from it, minus 1, which gives you negative 6. Okay, and that is our answer. So this is for 3 marks. So there is no really a requirement for you to, write the things that are negative, okay, as a positive exponent. You don't really have to write those as a positive exponent. At this point, it's okay. Okay, and because it's 3 marks, you're getting a mark for writing it in the format that it's supposed to be so that you can derive. You're getting a mark for that. You get a mark for each term, really. But this one, you didn't have to write it in that format. It already came in that format. And then you get a mark for deriving each of the terms. So you derive that and derive that. So that's 3 marks. Okay, moving on to the next question. Okay, so the next question, 7.3, says, for which values of x will the tangent to f of x is equal to this, okay, have a positive gradient. Okay, so first of all, let's look at the type of graph that we have. We have f of x is equal to negative 2x cubed plus 8x. So first of all, we can already see that this is a cubic function. And do you see that the a value, okay, that coefficient of x cubed, that a value is negative. When your a value is negative in a cubic function, your graph is going to look like this. It's really an n, like a capital letter N, but backwards. When it's positive, it's going to look like this. I also explained these in the other videos as well. So that is one thing that we need to think about. So it looks like this. And now what they're asking us is, we need to tell them the values of x for which a tangent, right? So if you had a tangent drawn to this graph, right, a cubic function, we need to find out the values of x for which that tangent's gradient is going to be positive. So let's break that down. Let's break down that question. They're saying the values of x for which the tangent to that will have a positive gradient. Okay, if there was a tangent drawn to this curve, right, you need to know something about tangents and curves. When you have a tangent drawn to a curve, all this means is that, you see at this point of contact with the tangent and the curve, the gradient of the tangent and the gradient of the curve are exactly the same. So think about it. If the gradient of the tangent and the gradient of the curve are exactly the same, what they're really asking you is, you need to determine the values of x for which this curve will have a positive gradient. Because if the gradient of the tangent is positive, then the gradient of the curve at that point is also positive. That's what they're asking you. So you need to determine the values of x for which this curve will have a positive gradient. Okay, so let's speak about positive gradients. So when a gradient is positive, let's actually explain that with a line. I'm trying not to take too much time in explanations. So when we're thinking about a line that has a positive gradient, that line is going to be an increasing function, meaning it's going to be moving up like that. So when you see a graph, okay, or curve, any type of function, and it is increasing, it means that its gradient is positive. So the cubic function has places where it increases and places where it decreases. Just remember that you need to read the increasing and decreasing from the left to the right. This is moving upwards, so it's increasing. So let's look at that with this graph. Which places do we find that the graph is increasing? Okay, so if we read it from the left, like just from here, right? Look at what the graph is doing. You always move from left to right. The graph is doing what? Decreasing. Then it does something. Here at the turning point, it stops decreasing, okay? It's neither increasing nor decreasing. Its gradient is standing still. It's stationary. That's why it's called a stationary point. So the gradient is equal to 0 at the turning point. Then what happens at this point over here? Let me highlight that in purple. What happens here? The graph starts to increase. So what does that tell you about the gradient? The gradient at this point is positive. Okay, so, and then of course at the next turning point again, the gradient stands still, is stationary, and then of course there it decreases. So this is the place that we're looking for. We're trying to find out for which values of x, okay, this graph has a positive gradient. We know that it has a positive gradient all through here. Now do you see an important point that you need to find in this f of x? It is the turning points. Because if you find the turning points, you will know that in between the turning points, whatever this number is, this graph is going to be increasing for values that are greater than whatever that first turning point x value is, but less than whatever that second turning point's values are. It's in between these two numbers. So that's the next thing we need to do. We need to actually find the turning points of this curve. So since we need to find the turning points, our equation, first of all, is f of x is equal to 2x cubed plus 8x. And how do we find the turning points? Okay, remember what happens at the turning points. The gradient is equal to 0 because it's stationary. Since the gradient is equal to 0, we're going to take this curve and find the gradient by deriving it. When you derive the function, you're finding its gradient. Okay, so negative 2 times 3, that gives you negative 6x. 3 minus 1 is 2, and then we have positive 8. And then, of course, you know it has an exponent of 1. You subtract 1 from it, becomes 0. Anything to the power of 0 is 1. And so 1 multiplies by 8 and just stays 8. Okay, great. We found the gradient of this curve. We want to find the turning point. The turning point, okay, has a gradient of 0. Hence, we are going to make the gradient equal to 0. So we're saying 0 is equal to negative 6x squared plus 8. Okay, then I'm going to go ahead and take this over so that it can become positive. You see, we're going to solve for x here. The x values are going to tell you the x values of your turning point. So that is 6x squared is equal to 8. And I can get rid of the 6. Divide both sides by 6. We have x squared is equal to 8 over 6. You see that 8 and 6 have a highest common factor of 2. So 8 divided by 2 is 4. And then 6 divided by 2 is 3. So this is what we have. So do you see that this is an equation? So we can get rid of this squared by square rooting. But when you square root, you need to remember that this is an equation. So you have two solutions. That exponent 2 has two possible solutions. Okay, so we're going to say plus and minus. And so x is either equal to positive, and you see when something is square rooted, the fraction, as a fraction, if something is square rooted, you really square root in the numerator and the denominator. So it's like square root of 4 over square root of 3. Okay, square root of 4 is 2, so that's 2 over square root of 3, because that's an irrational number. I cannot really square root that number. Okay, so that is positive 2 over square root 3, or x is equal to negative 2 over square root 3. Okay, so there we have our two x values of our turning points. Remember, all we need to do is tell them that. So we're going to have to put one here and one here. So since this one is on the left, it's the smaller one. That's what's going to go there. Let me just bring that graph down. Okay, so this is the values that we have. The one that will go here would be the negative one, because it's more on the left. So that's negative 2 over square root 3. It's the smaller one. And this one is positive 2 over square root 3. Okay, now that we have that, we know that the values of x for which this graph will have a positive gradient would be this. This is how I'm going to conclude this. I'm saying, therefore, it's where x is bigger than negative 2 over square root 3, because you see it's all of these values in between these two numbers. Bigger than negative 2 over square root 3, but smaller than 2 over square root 3. So I'm saying x is greater than negative 2 over the root 3, but less than positive 2 over root 3. And that is our answer. Okay, moving on to question 8. So we're done with that one. Okay, so moving on to question 8, more calculus. So question 8 says, given f of x is equal to negative x cubed plus 6x squared minus 9x plus 4. And they have also said it's equal to this, which is lovely because they've already factorized this for us. So we don't have to factorize it when maybe finding x-intercepts. Okay, so 8.1 wants us to determine the coordinates of the turning points of f. Okay, we just determined the turning points, or rather the x values, in question 7. So we now know how to do that here. Okay, so 8.1, to determine the turning point, you derive the function first. So that is negative 1 times 3, which is negative 3x. Then subtract a 1 from that 3, which is 2. Okay, and then we have positive 6 times 2, which is positive 12x. Subtract a 1 from that 2, which is 1. I don't have to write that. Then negative 9. And of course, the x falls away because it gets raised to the power of 0, which becomes 1, which multiplies to the negative 9. So now that we've derived it, we will set that equal to 0 to find the turning point. And then we have negative 3x squared plus 12x minus 9. Okay, so you can go ahead and factorize this. I'm noticing a common factor of negative 3 all through this. So I'm going to go ahead and just divide both sides by negative 3. And I'm going to have 0 is equal to positive x squared. And then positive divided by negative is a negative. So 12 divided by 3 is 4x. And then that gives us positive 3. Okay, so factorize. 0 is equal to, open up 2 brackets, x times x. Let's think about factors of 3 that can give us 4. Well, that can be 3 and 1. But you see that only the middle is negative, right? Because this is positive, the only way you could have gotten this is by saying negative 3 multiplied by negative 1. And that's how negative 3 minus 1 also gives you negative 4. So we have minus 3 minus 1. Okay, so this means that x is equal to positive 3, or x is equal to positive 1. So now that we have our x values, we can go ahead and find our y values because we need to find the coordinates of the turning points. So we're going to say f of 3. Now you don't have to go ahead and substitute the whole thing. You can just say f of 3, substitute, and find out those values. So I'm just going to do that. Okay, so what we get is 4. Okay, for substituting, we get that. And so the second one, we have to substitute the x value of 1. So again, f of 1, and I'll just go ahead and substitute. And then we get 0. So as you can see, that is an x-intercept. Now that's okay, it's still a turning point as well. So it's one of those situations where the graph is sitting on the x-axis, maybe something like that, like on the x-axis. Okay, so our turning points are finally, the first turning point is we have 3 and 4, so 3 and 4. And the second turning point is 1 and 0, which is of course also an x-intercept. So that is 8.1 done. Moving on to the next question. The next question says, draw a sketch of the graph of f, clearly label all intercepts with the axes and any turning points. Okay, so we just have to draw the graph. Let's think about all the things that we need when we need to draw a graph. You have your turning points. You also need your x-intercepts. So we can go ahead and solve that problem now. Let's find the x-intercepts. Let's talk about the y-intercept. This one is actually simple to solve in this case. So do you see that the function is in standard form and they also factorized it for you? In standard form, you see the last variable without any letter, okay? The last number is 4. That is going to be your y-intercept, okay? So it's that d at the end plus d. It's your y-intercept. Remember, the y-intercept always has an x value of 0. So your y-intercept as a coordinate is 0 and positive 4. So we got that sorted out. Now we just have to clear up the x-intercepts. The x-intercepts, they've already factorized this for you. So I'm just going to go ahead and say f of x is equal to, and I have x minus 1 all squared times negative x plus 4. And I'm just going to go ahead and simplify this. So as you can see, this format is the type where you have an x-intercept that is also a turning point. Just take note of that. So to find the x-intercept, we're just going to set these brackets equal to 0. So I'm really just saying that x minus 1 all squared is equal to 0, or negative x plus 4 is equal to 0. So in this, let's go ahead and just, the 0, if you like, you can square root both sides. You don't even need to say positive or negative because 0 is neither positive nor negative. So we have x minus 1 is equal to 0. Then we're taking negative 1 over, and so x is equal to positive 1. That's our first intercept. We already knew that one. And then this one, I will just take x over because it's negative. So 4 is equal to x. So we have 4 and 0. Okay. So these are our turning points, 4 and 0, and of course 1 and 0, but we already had that one. So we have everything now we need. We have our turning points, we have our y-intercept, and we have our x-intercept. Okay, so I'm just highlighting that because we already have that there. So just go ahead and draw your graph. Okay, so to draw the graph, let me just go ahead and draw a set of axes. So a y-axis and an x-axis. So here's our y-axis, and that's our x-axis. And I'm not even going to draw numbers on it because it's really not necessary. You don't really need the numbers. So now the next thing I'm going to do is just put down some points that we have. First point I can go ahead and put down are the turning points because it really helps to see the shape of the graph. So the turning points, let me start with the smaller one, 1 and 0. That is an x-intercept. So I'll say 1 is somewhere here. So I'm just going to put that 1. Okay, and then the next turning point is 3 and 4. So that is more on the right, 3, okay, and then 4 up. So I can even just use these lines, 1, 2, 3, 4, okay, 4 up. So that is a point that we have, 3 and 4. This one is 1 and 0. Let me actually highlight the points in red. So 1 and 0. So those 2 points are there. Then the next thing that we have is the y-intercept, which is 0 and 4. So remember, it is on the y-axis. Let me actually just label the axes. So it's on the y-axis and it's a 4. Interestingly, this has a y value of 4. So it's in line with this one. Here's your 4. Okay, so it's here, that point. Then the next point that we have is just 4 and 0. That's an x-intercept. 4 and 0, since this is 3 over here, 4 and 0 will just be more further to the right. So that's 4. So that is 4 and 0 as our x-intercept. Okay, so everything just looks very scattered right now, but we're just going to tie it all up together. You can easily see the way the graph looks because first of all, you have f of x is equal to negative x cubed. When the coefficient of a is negative, then your graph is going to look like a backwards n. So we already know that. Now you need to remember where your turning points are. Your turning points is this and this. So since those are our turning points, all we're just going to do is we know that this is where it's going to curve. Since it looks like that, it's going to curve like that. Okay, so our graph is just going to look like this. It's really just going to go like that, down and curve. Then it's going to go up and then reach there and curve and then go down, of course, touching the x-intercept. Let me just get that right. Okay, so there we go. That's what it's just going to look like, something like that. And you're really just getting marks for those important points. You see, it's only 4 marks. You're getting marks for labeling those points, or really they just want to see the shape of it and the points that you have. Okay, so that is question 8.2, and we're done with that. Moving on to the next question. Okay, next question. Question 8.3 says this. So it says you have to use the graphs, right? Use the graphs to determine the values of k, value or values of k, for which this, it's still the same function, but they're making it equal to k, will have 3 real and unequal roots. So they have to be real and unequal. Okay, let's start off by looking at what we have here, right? They said negative x cubed plus 6x squared minus 9x plus 4 is equal to k. This is the equation that they gave us, right? They're making this equal to k. We need to find out the values of k for which it's going to have 3 real and unequal roots. So first of all, take k over. So we have negative x cubed plus 6x squared minus 9x plus 4 minus k is equal to 0 because there's nothing here now. So that's the roots, right? Where this is to find the roots. So we need to find out the values of k for which that graph is going to have 3 real and unequal roots. Okay, let's look at the way this graph looks right now. This graph currently has how many roots? It has 2 roots, okay? Those are x-intercepts. It has 2 x-intercepts. We need it to have 3, and they need to be real. Another thing that we should also take note of is the fact that this k is negative, but we'll get to that. Let's just look at this quickly. Okay, so how should we move this? Well, if you look at k is saying negative k. So it's already indicating that we're going to have to move down. Okay, it's already minusing. Well, it's not indicating it for you. It could have also been positive. Then you would have had to just sort that out yourself. But it's negative, and right now it's really in our favor. So it's negative, but let's look at this graph. How can we move this graph in a way that it's going to have 3 roots? Well, it has 2 roots right now. If you think about it, if you move the graph up, right? Like if the graph looked like this, it will only have 1 root. And we don't want that. We want it to have 3 roots. Okay, what if you decided to move the graph down? Like from where it was, we move it down. Look at what happens when you move it down. Do you see that you have a root here, here, and here? 3 roots. That's what you want. If you keep moving it down, it keeps having 3 roots, 1, 2, 3, until you move it to this point. Then it has 1, 2 roots. So you see that if you move it anywhere within this region, you're always going to have 3 roots, and that's what we want. So how did we move the graph? We moved it down. So we know that we need to move this graph down. That's great. But how far down should we move it? Well, let's measure how far down. It was here at first, right? So we can focus on this, 3 and 4. You see that y value is 4, right? When we moved it down to this point, what is the y value now? The y value is 0. Okay, so you moved it down by how many units? By 4 units. So this is how we can think about it. Because this already says minus k, it's really in our favor. It's already telling us, okay, we're moving down because it's a minus, and that's great. So we just need to tell them by how many units we need to move. Okay, we don't have to manipulate that number, think about whether it's going to be positive or negative. It's already minus, telling us we're moving down. So how far? Well, first of all, if you move it anything more than 0 units, because moving down already, right? If I move 1 unit down, I have 1, 2, 3 roots. 2 units down, 1, 2, 3 roots. So if I move it anything more than 0 units, it's going to have 3 roots. But I shouldn't move beyond what number? I shouldn't move beyond 4 units. Because when I reach 4 units, then you see that this now has 1, 2 roots, 2 x-intercepts. Okay, so that's what I can say here. I can say that the value of k just needs to be, it can be anything more than 0. It can be greater than 0, right? It can move anything more than 0. It can move 1 unit, 2 units, but it must not move beyond 4. So it must be greater than 0, but less than 4. And they made it really simple by putting a positive k there, so we didn't have to overthink the whole thing. Okay, so that is the answer for that question. Moving on to the next question, we have 8.4. Okay, so 8.4 says this. It says, the line g of x is equal to ax plus b is a tangent, okay, to f at the point of inflection of f. Determine the equation of g. Okay, this is not a bad one. It's actually quite a simple one. They're telling us that, you see this graph that we have, remember it looked like that. There is this graph g of x, and g of x is a tangent, so it's a straight line. So we have this tangent to this graph, but it's a tangent at the point of inflection. Well, the point of inflection is really just the point where this graph changes from concave up to concave down. That's all. So it's a tangent at the point of inflection. So it's kind of like, let me just try and get that right. Something like that, right? It's at the point of inflection. It's touching there. So how do we find this equation of g of x? Well, we have the equation of f, which is great. And they told us that this is a tangent to this at the point of inflection. This tangent is a straight line. In order to find the equation of a straight line, you just need the gradient of the straight line, right? And you just need at least 1 point so that you can go ahead and use that to find c, or the y-intercept, okay? In y is equal to mx plus c. So how would we find the gradient of the straight line? Well, unfortunately, you don't have 2 points that you can use to find the gradient. So we're not going to find the gradient using the traditional method, but we do have the equation of f. We have f of x. Since we know f of x, we can derive it to find the gradient. And we're going to derive it to find specifically the gradient at the point of inflection. That's what we're going to do to find that gradient. Okay. But you see now, in order to do that, you actually need the point of inflection. So you need the x and the y value. Well, just the x value for the gradient, but you need a point. So first things first, we need to find that point of inflection. Let's go ahead and find that. Since we know that the equation of this graph or function is f of x is equal to negative x cubed plus 6x squared minus 9x plus 4, to find the point of inflection, remember, you get the second derivative and set it equal to 0. So let's first of all derive, which we already have, but I'll just derive quickly. So that's negative 3x squared plus 12x minus 9. Then derive it again. And so this is going to be negative 6x. When you subtract 1 from there, that becomes a 1. You don't have to write that. Then plus 12. The x falls away, remember, because x to the power of 0 is 1. Then you're going to make the second derivative equal to 0. So we have negative 6x plus 12. Then we're going to take this negative 6 over, because it's negative, so positive 6x is equal to 12. Divide both sides by 6, and so x is equal to 2. Here's our point of inflection, the x value of our point of inflection. And that's great. We can just go ahead and just find the y value of the point of inflection while we're at it. So the y value of the point of inflection, how do you find the y value? it's a point, okay? So it's on the graph. So to find its y value, take the x value and substitute it into the original function so you can get its corresponding y value. So that's going to be f of 2 is equal to, and I'm just going to substitute. So f of 2 is equal to 2. That's what we get. So that is 2. The y value of the point of inflection is 2. And now lastly, what do we have to find? We have the whole point, right? The point of inflection, the point on this straight line is 2 and 2. Okay, so now that we have the point of inflection, what else do we need? Remember, we needed a point and the gradient of this line. Okay, to find the gradient of the line, we're going to take the derivative, we're going to derive it, and then find out exactly what the gradient at this particular point is. That would be the gradient of this tangent. So the gradient at where the x value is equal to what? We found the x value of that point of inflection. We'll find the gradient where the x value is equal to 2. So I'm saying f prime of 2 is equal to, and I already have the gradient of that. So f prime is equal to negative 3 times 2 all squared plus 12 times 2 minus 9. And just substitute that, and this will give you the gradient where the x value is equal to 2 of this function. Okay, and we can see that that gradient is equal to 3. So we have the gradient of that tangent. It's equal to 3. Okay, and now almost everything is done. So remember that g of x is equal to ax squared plus b. That is just a straight line. You can go ahead and find the equation of a straight line. So we're saying y is equal to mx plus c, and we know that our gradient is 3. So we're saying y is equal to 3x plus c. And now in order to find c, you need to substitute a point on that straight line, which is the point of inflection 2 and 2 that is on the straight line. So we're going to just say 2 is equal to 3 times 2 plus c. And so 3 times 2 is 6. So we're saying 2, and then positive 6 is coming over, minus 6 is equal to c. So c is equal to what's 2 minus 6? Negative 4. So it finally means that y is equal to 3x minus 4, and that is the equation of g of x. Since they didn't say write it as y, I would just write that as g of x. I'll say g of x is equal to that, and that is our equation. Okay, so that is 8.4. That is a question that can come up in different ways, really. Moving on to the next question, 8.5. Okay, so the last question says calculate the value of theta, the acute angle formed between G and the x-axis, in the first quadrant. Okay, so it's the angle formed between G and the x-axis in the first quadrant. So just look at what G looked like, right? G of x was this straight line. So if I just erase this, really what they're just saying is, okay, this straight line of G, right? You have your x-axis. You need to find the angle of the acute angle, okay, formed by the x-axis and that straight line. That is the angle of inclination of this G. Okay, so that is the theta they're talking about. So if you have to find the angle of inclination of a line, you know that this is G, of course. So the angle of inclination, theta, you find that by just saying tan of theta is equal to the gradient. What is the gradient of G? Well, we found that. We know the gradient of G is 3. So tan of theta is equal to 3. And then I'm just going to find theta. So I'll say theta is equal to, we are going to take tan over, or in other words, you're just going to find the inverse of tan. So the second function of tan and then of 3. So you can just do that on your calculator. So we're saying shift tan of 3. Okay, so did they say anything about rounding off? No, nothing like that. Okay, so theta is finally just equal to, we'll round off to 2 decimals, 71.57 degrees. Okay, so that is that. It seems like a question they just decided to throw in. That would really just help. It's 2 marks. It's a good question to at least just throw in to help to increase the mark. Okay, so we're done with question 8, and now we finally move on to question 9. Okay, so for question 9, I just decided to increase this because I really couldn't see what's going on. Okay, so they say the diagram below represents a printed poster. So this is a printed poster, okay? Then they say rectangle ABCD is the part on which the text is printed, okay? This shaded area, ABCD, is 432 centimeters squared, and AD is equal to X. So they're telling us a lot. They told us the area of that shaded part, and they told us that AD is X, okay? Then ABCD is 4 centimeters from the left, okay, left and right edges of the page, and 3 centimeters from the top and bottom of the page. So 4 centimeters and 3 centimeters like that, okay. The first question is for us to show that the total area of the page is given by this equation. Okay, so you see the whole goal is find the area of that entire page. That's what we need to do. Okay, 9.1. How do we find the area? Well, you know that the area of this shape, a rectangle, is always going to be length multiplied by breadth. That's all, right? So let's see if we can find each of them, the length and the breadth. If we can find expressions for them, of course. It's not going to be a simple number because this is in terms of x. So an expression for the length, first of all. How do we find the length of this? Well, do you see that they told us that AD is x? And we know that this, right, from the left and the right, they're both 4 centimeters. So if you add them all together, that's 4 centimeters plus x plus 4 centimeters. So the length of this page, we can just call that, since it's 4 plus x, we can just call that x plus 8. I'll just call it x plus 8. It just looks better as the x that's in first. So that sorts out the issue with the length, right? It's in terms of x, and this is in terms of x as well. So now we have to find out exactly what the breadth of this page is going to be. Okay, so to find the breadth of the page. So the breadth of this page, this entire thing, we also know that this is 3 centimeters. So if you count, it's like 3 centimeters, also 3 centimeters, 3 centimeters. But what's AB? How do we find AB? Well, that's probably where this comes into play. So they said that ABCD, the area of it is this. So how about we find an expression for the breadth using this information? They told us that AD was x centimeters, right? So to find the area of the page, that's the area of, not really page, sorry, the shaded part, first of all, we can use that to find an expression for AB, because that's what we need. We need an expression for AB, okay? So the area of, I'll say shaded, right? That's what we're looking for. Okay, so that would be, of course, the AB multiplied by the AD, which would give you that area, which they told us is 432 centimeters. But remember, you know, we have AD already. So I can just say that we already have that as X. Okay, so since we already have AD as X, to find AB, we can just go ahead and make this the subject. How do we make AB the subject? Well, X is being multiplied to AB. So to get rid of the X, we're going to have to divide both sides by X. And of course, X is not equal to 0 because it's a length. Length cannot be 0 because this is a physical page we can see. Okay, so AB is equal to, that just is 432 over X. That is the expression for AB. So this now makes finding the breadth of this page easier. So to find the breadth of this page, we're just going to say it is that AB, right? That piece, which is this 432 over X, plus that 3 centimeters, because that's what fills up, that's what makes up the entire breadth. The 3 centimeters plus the 3 centimeters, which is 6 centimeters really. So this is an expression for the breadth of this entire page. Okay, great. We have the length and the breadth of the page. How do you find the area now of the page? So area of page. Area of page is always going to be length times breadth. So the length that we have is x plus 8. That's x plus 8. The breadth that we have is this. It's also 2 terms, so I'll put a bracket. So 432 over x plus 6. And now we just have to simplify. Okay, since they said a of x, I'm also just going to say a of x is equal to that. Just simplify by foiling out. Okay, so we're saying is equal to, and we're going to distribute this out. Let me just push this up a little bit. So if we distribute it, you're saying the x multiplied by this. You see, if x multiplies by 432 over x, the x and x are going to cancel diagonally. That's gone. So you only have 432 left there. Then the x multiplies by the positive 6, which gives you positive 6x. Then the 8 is going to multiply to this. Okay, and as you can see, 8 times this as a fraction, 8 times 432 over x. The 8 and the 432 are just going to multiply. So let's just find out what exactly that's going to be. 8 multiplied by 432, that gives you 3,000. So this is going to be positive 3,456, and then over x. The x is not cancelling here because there's no x here to cancel. Okay, that's what we get there. And then 8 multiplied by 6, that is going to be plus 48 that we get. Okay, so this is what we have. Just make sure that all your like terms are together. So it means that a of x is finally equal to, and we're saying, since they put that first, I'll also just put it first. So 3, 4, 5, 6 over x, then plus 6x that we have. And then, of course, the 432 plus 48. So that's going to be positive. Well, 32 plus 8 is going to be 40. So 40 plus 40 is 80. So that's positive 480. And it's exactly what they have there. So there, that is our final answer. So we got that. Okay, next question, 9.2. 9.2 says, determine the value of x such that the total area of the page is a minimum. Okay, so they're not asking for the area that will be a minimum. They're just asking for the value of x. That's all. So how do you find the value of x for which this is going to be a minimum? You're going to have to use calculus. So this is a question that probably grade 11s will not be able to solve. The reason why is because, as you can see, this is not even a parabola. Okay, grade 11s can solve the ones that have parabolas because you can just use turning points equation. But since this is calculus that we're just going to have to use to find for which values of x something will be a minimum or maximum, you first derive that, okay, and you set it equal to 0. And the idea is that at the minimum or maximum value, okay, of a curve, that's usually the turning point. The turning point is a place where the gradient is standing still, so the gradient is equal to 0. That's why we derive and make it equal to 0. Okay, so now that we have this, we're just going to have to derive that. But I can see it's not ready to be derived, so let me just rewrite it. You see that x needs to come to the numerator. So we have 3, 4, 5, 6. X raised to the power of negative 1. That's what happens when it comes to the numerator. It's positive 1 exponent becomes negative. Then everything else is fine. So 6x plus 480. Okay, now we can go ahead and derive. So we're going to say a prime of x is equal to this multiplied by negative 1 is just negative 3, 4, 5, 6. X raised to the power of negative 1 minus 1 is negative 2. Then we have positive 6. Positive 6, and of course the x, 1 minus 1 is 0. Anything to raise to the power of 0 is 1, and so it multiplies to the 6 and stays 6. So this is what we have. It's the gradient of this function. We're going to set the gradient equal to 0. And so it's negative 3, 4, 5, 6, x raised to the power of negative 2 plus 6. Okay, I'm going to take this over since it has a negative value, right? It's negative. So positive 3, 4, 5, 6, and x, I can bring that to the denominator so that x exponent, the exponent on x can become positive 2, is equal to 6. Okay, then in order to solve for x, we can go ahead and just cross multiply. Or we can also just look at it as, oh, I'm going to move this over there and move that over there. But let me just cross multiply so that it doesn't, look confusing. So cross multiplying, that's going to be this multiplied by that is 6x squared. Then this multiplies by this denominator, which is actually a 1. Okay, and that is 3, 4, 5, 6. Then we can divide both sides by 6. Hopefully that number divides by 6, but it doesn't matter. Divide by 6. Okay, it does. So x squared is equal to 576. Then this is saying x squared. So you need to find the square root of both sides. So square root both sides but it's an equation. When you square both sides, this is going to be positive or negative. So either x is equal to, what is the square root of this number? So I'm just going to say square root of 576, and that is 24. Either x is equal to positive 24 or x is equal to negative 24. Okay, let's think about that carefully. Remember what x is, right? X is a length. It's a distance. Can we ever have a negative distance? No. Even if you walk backwards, it's not going to be negative, okay? Because you're still covering a space, so it's positive. So we cannot even take this one. Therefore, it means that x is actually equal to positive 24 centimeters, and that would be our minimum value. Okay, so that is it for question 9, and we're done with that. We can finally move on to question 10, probability. Okay, so we're on question 10, and 10.1 says this. It says A and B are independent events, okay? The probability of A is equal to 1 over 3, and the probability of B is equal to 3 over 4. You need to determine the probability of A and B. You need to remember what all of these things means. You know, they always mention this thing at first. They always say they're independent, or they would say things like they're mutually exclusive. You need to know what it actually means. If events are independent, what it means is that the probability of A and B would be found by finding the probability of A and multiplying it to the probability of B. That's what independent events mean, right? So since we know that now about independent event, we can use this to actually find what they're asking us for. They want us to find the probability of A and B. You see that this is the perfect equation for it, okay? So to find the probability of A and B, we're going to use what they gave us as well. They told us the probability of A is 1 over 3. That's 1 over 3. Multiplied by the probability of B, which is 3 over 4. And if you multiply those two, you're going to get your answer. So that is 1 times 3, which is 3. 3 times 4, which is 12. 3 over 12. They have 3 as a common factor, so divide by 3. That's 1 over this. Divide by 3 is 4. 1 over 4. That is your answer. Okay, so that is the first question. Always take note of when they say these things, okay? Remember what independent events do. Remember what mutually exclusive events do. Remember, I do also have past paper videos. You can go there. Most of them, no, all of them, all the grade 12 videos have timestamps. I know that it's only 3 grade 11 videos I posted recently. I didn't put any timestamps because of the time. So you can always just skip to question 10 and actually watch the probability so that you can practice more and start understanding what they mean by certain things. Okay, moving on to the next question. Okay, so the next question says we need to find the probability of at least one event occurring. At least one event. This is another thing that you can check out my video on Venn diagrams. I'm going to link it. I will show you the actual video and probably link it in the description as well. And that really explains those things they speak about when they say probability of at least one and things like that. Okay, so I'm just going to explain this briefly. At least one of the events occurs. The only events they mentioned is A and B. That's all, right? In a Venn diagram, right? Because these are independent. When you're thinking about probability of at least one event occurring, let's look at it like this, even if they intersected, right? We have A and B. If you're trying to find the probability of at least one event occurring, at least one just means at lowest one event must occur. So you need to take the probabilities of everything that has either one or more events occurring. The amount of events we have here is just 2, A and B, that's all, right? In this part, right, let me just highlight that like that. How many events are occurring in this region? It's only the probability of A, only, without the probability of B. So how many events are occurring here? That's one event. So we would take that. What about in the middle, the intersection? How many events are occurring here? That's 2 events because A and B are occurring here. So we'd also take that because we need to take at least one, meaning at lowest one event must occur. You can take 1, you can take 2, as long as it's above 1. And then here, how many events are occurring in the circle of B in this part without the intersection, of course? That would be 1 because the probability of B is occurring here. So do you see that we actually have to take everything here? Meaning this is the entire circle of A and B, everything here. This is really just finding the probability of everything. So probability of A or B. In other words, it's the probability of A union B. Everything. The combination of A and the combination of B. Everything. That's what we're finding. Okay? Just nothing outside the circle, of course. So that's what they're actually asking us for. They're asking us for the probability of A or B. So let's go ahead and find that. Well, all we have right now is the probability of A, we have the probability of B, and we have the probability of A and B. You can use the addition rule of probability of A or B. The addition rule states that probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And please check out my Venn diagram video. So I actually explain why we subtract that intersection. It's not because we are excluding the intersection, okay? You find out more about that in that video. So this is what we have. This is finally equal to, what's the probability of A? It is 1 over 3 plus the probability of B, 3 over 4 minus the intersection of A and B, that's A and B, 1 over 4. Minus 1 over 4. And then we can just find that answer. You can go ahead and do this by yourself, but you can just use a calculator, which I will. Okay, and that answer is 5 over 6. And there we go. Okay, so that is it. 5 over 6 is the probability of A or B. That is the probability of at least one event occurs. Just to be a little accurate, what I would actually say is exactly what they said as well. Just so that it looks like, yeah, I actually am talking about this. So I would say probability of at least one event. Okay, so there we go. Now we can go ahead and move on to the next question. So we're done with that scenario. Okay, we have 10.2 now. So 10.2 says, the probability that it will snow on Drakensberg Mountains in June is 5%. Okay, then they say, when it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 72%. Then they say, if it does not snow on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 35%. Okay, so first of all, notice that we're hearing a lot of this if this happens and if that happens. Okay, if it does not snow, right? That language is usually used in tree diagrams. This is probably a situation where we have dependent events because these events are being affected by previous events. So something happens and then it causes an effect on the next thing that is going to happen. Okay, so these are dependent events and we can already see, okay, this is going to be a tree diagram when you start reading the information. The first question is for us to represent the given information in a tree diagram. On a tree diagram, clearly indicate the probabilities associated with each branch. So just the probabilities associated with each branch, not the outcomes. Okay, so that's all we need to do. Let's break down this tree diagram. So they say the probability that it will snow on Drakensberg Mountain is 5%, of course, in June, right? So that it will snow. But then they said when it snows on the mountain, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 72% when it snows. Okay, so this is clearly something that happens after it snows. So in the first branch, we have a situation where we're speaking about whether it's going to snow or not, right? So I'll call this snow, right? And then what is the probability that it's going to snow? They said the probability to snow on Drakensberg Mountain is 5%. As a fraction, that is 5 over 100. So the probability that it will snow is 5 over 100. So that means by default, the probability that it will not snow, let's say not snow, that would be what is left. 100 minus 5 is 95. 95%, right? So 95 over 100. I need a little more space for this tree diagram. Okay, so that's what we have first from that first statement, okay? When it's going to snow, it's 5%. Then they say, when it snows on the mountain, when it snows, the probability that the minimum temperature, so the minimum temperature will drop below 0 degrees is 72%. So this is at the snow column. We're saying if it snows, right, the probability that it's going to drop below 0. So we have another category now, below 0, right? The probability that it will drop below 0 is 72%. So that's 72 over 100. So if this category is below 0, what would be the category that is the opposite of this one? Okay, so it's either it's going to drop below 0 or it's going to be above 0. So we're just going to say, I'm going to call this one above 0. Technically above or equal to 0, because it could be 0 degrees as well, but I won't also just get too technical with that. Okay, so I just put it like that, above or equal to 0. Okay, so then that is going to be what? If we already know this one is 72%, when you add them together, they should give you a total. So what is left of this? So 100 minus 72, that is 28. So that's 28 over 100. That will be the probability that it's going to be above or equal to 0. Then here we have not snow. Let's just keep reading and see what we have. If it does not snow, right, on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 is 35%. So this is in the column of it will not snow. The probability that it's going to drop below 0 again, below 0, that is going to be 35%. So 35 over 100. So what is the alternate one, okay, where it's going to be above or equal to 0? Honestly, I feel like they would just say above 0. I'm being too technical here. Okay, so 100 minus 35, that's going to be 65%. So 65 over 100. Okay, so that's what we have all through here. And that's all. Because they didn't say anything about multiply the branches. When they want you to find the branches being multiplied, then they will say, and also represent the outcomes of all the events being occurring together, really. Okay, they would say it in a more, put together way. So, but here they really just said, you have to draw it down and write down the probabilities associated with each branch. Okay, not really all of the outcomes, like combined. So that's all we need to do there. Next question, 10.2.2, they say, okay, calculate the probability that the temperature in central South Africa will not drop below 0 degrees Celsius in June 2024. So this is a prediction we're going to make based on the probability. But we need to be very careful as we do this. You see that they don't say that calculates the temperature, right? If it snows, that the temperature will not drop below 0 degrees. They don't tell you about whether it's going to snow or not snow. They only mention about it not dropping below 0. So we need to take everything that does not have below 0. Okay, everything that does not include the temperature dropping below 0. Okay, so here it drops below 0. We cannot take that one. Here it is above or equal to 0. We can't take that because this is not that case. Okay, it's not below 0. We need to take the case where it is not below 0. So we're going to have to take this, and we're also going to have to take this one because this one is also not below 0. But do you see now these are independent events? You cannot just take the events and then add it up together. They are happening together. Okay, it's either snowing or it's not snowing. Then it's going to drop above. It's going to be above 0 or below 0. That's how it's working. So you need to also, along with this, you're going to also take the branch that happened before it. So we need to take the probability that it's going to snow, right? And the temperature drops above 0 degrees. Okay, that's the first part we're taking. We're taking that. We're going to take the probability of it's snowing and the temperature is going to be above 0. I'm just going to call that above 0, right? And then is that the only one we're going to take? No, we're also going to take this because here it's also above 0 degrees as well. But the branch that was attached to this, right, the thing that happened before it, was this: it did not snow. So we need to take the probability that it's not going to snow as well. So we're taking that probability that it's going to not snow, and the temperature is also going to be above 0. That's what we're taking. Now, what are we doing with these? Well, if you look at it in a language sense, what they asked you when they told you to find out the probability that the temperature will not drop below 0 degrees is you need to take everything that does not have below 0, right? So what we're saying is that means we can take the probability that it will snow and the temperature will be above 0, or we can take the probability that it's going to not snow and the temperature is going to be above 0. So what does this word "or" mean? In probability, "or" means to add. Again, if you watch the Venn diagram video, you will see why all these things mean those specific things, okay? "Or" means to add, and I do explain it there as well. So what we're going to do is take that probability and add it to this probability. So the probability that it will snow and be above 0 is what? Well, you're going to have to multiply them, because that's how we find the total probability of these two events happening at the same time. So that is the 5 over 100, right? Multiplied by this. So we're going to take the branches and multiply like this. The probability that it's going to snow and it's going to be above 0. That's 28 over 100. Let me write this bigger. 5 over 100 times 28 over 100, right? We're going to take that. And because we have "or," it means to add. So we're adding that to the probability that it will not snow. Probability that it will not snow is 95%, right? Multiplied by, so probability that it will not snow and be above 0 degrees, which is 65. So 65 over 100. And we'll get our answer like this. Okay. So really we're just adding these two together. Okay. In an exam setting, I'll probably write this a little neater. And I get an answer of 1,263 over 2,000. And I like to leave things like that. I don't actually like writing things as decimals because I feel like some parts of it is cut away. Like this, I can get the percentage even. Like it just feels more put together. Okay, so that is the answer. You can leave your answer as a percentage, as a decimal, as a fraction. It's still fine because it's probability. We're done with 10.2. Now we move on to 10.3, which is the last question. And okay, let's go. So 10.3. In 10.3, you see that they say 10 learners stand randomly in a line, one behind the other. Okay, so 10 learners. Now, I like to visualize what's going on. So I'm just going to put 10 learners, right, standing in a line. Okay, so there's our 10 learners. And they say the first question is 10.3.1. 10.3.1 is asking, in how many different ways can the 10 learners stand in the line? Okay, so how we calculate that is like this. You're going to look at it like this. The first learner, when they have to stand in a line, they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 choices, okay, that they can stand in. They can stand in either the first, second, all the way to the 10th position. So that learner has 10 choices. Then after the first learner is standing, then the second learner has how many positions to stand at? 9 more positions, right? The third learner will have 8 more positions. Fourth, 7, fifth, 6th, 5 more positions, 4 more positions, 3 more, 2 more, and 1 more. And all of this on the calculator is called 10 factorial. So 10 factorial, you can just go ahead and find out what that is on the calculator. 10 factorial, you just press shift and then that button with the x to the power of -1. And we get, so 1, 2, 3. Okay, so 3,628,800 ways. These are the different arrangements that they can stand in. Okay, that one was okay. It was good. It's quite simple. The next question, 10.3.2. Okay, so for this last question, I just decided to expand the page because it's really the last question. I'm not really going to need the question paper anymore. So the last question says, Calculate the probability that there will be 5 learners between the 2 youngest learners in the line. So you have the 10 learners standing, right? And the question wants us to calculate the probability. So let me also just remember they are asking for probability that there will be 5 learners. So 5 learners between the 2 youngest learner in the line. So we have 2 youngest learners and we need to calculate the probability that there's going to be 5 learners in between them. So let's think about that. If the 2 youngest learners, let's just say a first scenario can be like this. So let's say this is one of the youngest learner and then there's supposed to be 5 learners in between them. So 1, 2, 3, 4, 5. Then this would be the second youngest again. Okay. So if we're thinking about this, let's also just give them names. I thought about giving them names, like actual names, but I feel like that's going to get confusing. So I'm going to just call them youngest learner 1 and youngest learner 2, right? So let's look at how this can work. We have to find the amount of ways that they can be seated, but there needs to be 5 learners in between the both of them. Okay, so how do we make sure that this youngest learner, they're always going to be in between the 5 learners, not the 5 learners, but just 5 learners. Okay, they didn't specifically say that these are 5 particular learners. So let's think about all the ways they can stand. Well, the first way of them, they could stand like this. Okay. And a second situation is where the youngest learner can be standing here, for example, right? That can be the youngest learner. And then that's the youngest learner again. Either ways, in this placement, we can still see that there are still 5 learners in between the both of them, the 2 of them, right? Still 5 learners here. So they can either be standing in the first, and let me actually write that, the first and the 7th position, or they could be standing in the 2nd and the 8th position. Let's also keep seeing the other ways that they can stand. Or they could be standing in the 3rd and the 9th position, and in the 4th and the 10th position. These are all the ways that they can be standing, and 5 learners will always be in between them. Okay. But I also have to think about the fact that these learners, right? The first learner, the first youngest learner, doesn't necessarily have to be standing here. The first learner can actually be standing here. So they can actually switch places because technically there's still going to be 5 learners between them. So we can also have situations like that as well. Okay, I'm going to really just think about this question first. Okay, I thought about this question for a while and it was not making, well, the question makes sense. I understand the question, but getting to that answer. So the thing about it is, we're looking at this and we know, yes, the first learner, the first youngest learner and the second youngest learner, they can switch places, right? They don't always have to stand in these 2 positions. So if you look at the amount of ways that the 2 youngest learners can stand, there are actually 2 ways that they can stand. They can either stand as learner, first youngest learner and second youngest learner, or second youngest learner and then first youngest learner. So from them, I'm seeing that, okay, that's 2 ways that they can stand. 2 ways, which I usually like to call 2 factorial, right? But now I have to think about this 5 learners in between. I thought about the fact that, okay, there are 5 learners in between. So why didn't I just say, okay, 5 learners have to be in between them. So I can say 5 factorial. But the thing about this, and the reason I kept thinking about this and saying, I don't know, I don't think I can actually do this, is because when you say 5 factorial, what you're doing is you're creating a group. So you're saying that these particular 5 learners have to be standing, okay, in between the 2 learners. Now, the thing about that is that may seem correct. That may seem like, yes, that's true. They're supposed to be standing there. But this question doesn't give any indication that there has to be these particular 5 learners standing in between the 2 youngest learners. That's the issue that I'm seeing here. It wasn't specific about that. You see, they didn't say, they said calculate the probability that there will be 5 learners, not that there will be 5 specific learners, right? Like 5 particular learners. Only these 5 learners can be standing in between them. It doesn't say that. So with that being said, it means that, for example, this learner could be one of the 5 learners here as well. And this learner could also be one of the 5 learners here. And that's the reason I keep on not wanting to say 5 factorial, because 5 factorial means you're creating a group. You're saying these 5 particular learners must stand in between the first and the second youngest learner. So, okay, this is the conclusion I'm coming to. What I'm going to do here is find out the possible ways that we can actually have this particular arrangement first. This arrangement can be viewed as like this, basically. We can look at it as the first and the 7th learner is going to be the 2 youngest, or 2nd and 8th, and so on, right? But then remember that these 2 youngest learners, they're not the same people. They're 2 different people. So we can also have situations where the youngest learner, the 2nd youngest learner is first, and then the 1st youngest learner is second, right? So I'm also going to put those probabilities as well. So it's going to be exactly this, but just having y2 and then y1. Okay, so I know it looks a bit crazy, but this is what I'm thinking of now. So looking at the positions, the possible positions that they can be standing in, this would be everything, right? They can either be in the 1st and 7th position as y1 and then y2, or as y2 and then y1, right? And the 2nd and the 8th, and of course we can see the orders of them. So you see that there's 8 possible categories that we can have, right? 8 sort of arrangements. This is not obviously the final answer. 8 sort of structures that they can be standing in. But now we also have to look into each of these. So if I could find the amount of ways for each of these, I could just add them up together and then find the final answer. I know it's a messy way, but I'm really just trying to unpack everything, really. Okay, so in this first arrangement, right, I'm looking at the 2 youngest learners, they're standing like this. I don't have to say, oh, there are 2 ways now that they can be standing like this anymore. The reason why is because I already have that second situation here, which I will calculate separately. Okay, so since these 2 learners are already standing like this, what are the possible ways that everybody else can be standing if 5 learners have to be in between the 2 youngest learners? Now, considering the fact that it's not 5 specific learners, right? Like 5 particular learners like Tandy, Bob, Josh, and 2 other learners have to be standing in between the 2 youngest. It's not 5 particular learners. It's just 5 random learners. So for example, this learner could be in here as well, part of the 5 learners. Okay. And then that maybe one of them could be there. So that's the thing I'm thinking of. And that's why I don't want to group them. I feel like grouping them is a dangerous thing now, because now I'm creating this group and saying that these particular 5 learners must be standing here. And it doesn't seem like what they're asking for. They're saying just that there will be 5 learners between the 2 youngest in the line. So by that logic, we have to look at it like this. These are 8 individual learners. They can be standing as, for example, this learner can be here, for example, and then this learner there, right? Since they have the freedom to move around like that, but there has to be 5 learners in between, right? I'm still going to have to look at it like this. After the 2 learners are standing in their positions, 2 youngest learners are standing, how many more positions are there for a learner to stand in? There would be 8 more positions. So for example, this learner could either stand here, here, that's 2, 3, 4, 5, 6, 7, and 8. 8 places that this learner would have a choice to stand at or stand in. So that learner will have 8 choices. Then after that learner is standing, then the next learner would have how many more places that they can stand at? 7 places. And then 6 places. And so 5, 4, 3, 2, 1, which is really 8 factorial, right? Because I'm really trying not to group them. If I group them, I'm saying that these 5 particular learners must be standing here. So I'm taking out the arrangements individually and actually going to calculate it. They'll probably look the same though. The way I'm thinking about it, it really feels like it's going to all look the same. Because the thing about counting principles, right? They only tell you the information. They don't show you how it looks. You can find out, for example, right? Maybe there's even like a 5 out of 98 chance that these 2 learners can be standing between 5 learners. But the counting principles will not show you how they're standing. they're just going to count the amount of ways they can be standing in that order and then just give you the number. So I'm actually representing it out like this. I'm trying to think about all the possible ways and represent that, then calculate it individually. So this is one category that we're looking at. And I'm saying that these 2 learners have to be standing like this. And the 8 learners get to move around really. Like this learner, for example, doesn't have to particularly be here. This learner could be there. And then this learner could be here, right? And so that's why I'm still saying 8 factorial there. If you look at this second case here, it would be the same thing. These 2 learners have to stand here. Then the rest of the learners would have how many positions to stand at? 8 positions. So this one, for example, would get to stand here, 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 or here. That's 8 positions. Then after that one is standing, this one gets to stand either here, 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 all the way to basically 7 positions, and then 6 positions, and then 5. That will also be 8 factorial ways that they can stand. Okay, given that these 2 learners are standing here. And then this one, same thing. These 2 learners are here. That will also be 8 factorial ways. 8 factorial, right? For these 8 categories, they're going to be 8 factorial. So if you look at what's going on, what we're doing is we're adding 8 factorial 8 times. That's what it seems like we're doing. Adding 8 factorial 8 times. So that would be 1, 2, 3, 4, 5, 6, 7, 8, right? In other words, you can decide to add 8 factorial 8 times, or you could have just said 8 factorial times 8. Okay, so 8 factorial times 8 is going to be 8 factorial multiplied by 8, and that is 322,560 ways, right? But also do remember that they did say you need to find the probability. So you see, I'm trying to find the categories out by hand. Then we have to put this as a probability, right? So it's going to be this, right? In other words, 8 factorial times 8 over the total number of ways that they can stand, okay, if they were not being grouped or manipulated in any way. And we know that total number of ways was 10 factorial, the 10 learners, right? So over 10 factorial. And then I'll just simplify that. And this gives me 4 over 45, which I think it can be simplified to, you can leave it as a decimal as well. I think that's recurring. Yeah, it's recurring. So 0.89 as a decimal, but I actually do like leaving it as a fraction. So that would be my answer there. But yeah, we'll see when the memo comes out. So that is it for this video. If you've enjoyed this video, feel free to give a like on this video and subscribe for more content like this. And I will see you guys in the later videos. Bye for now.